It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Hello everyone, good afternoon to all. Am I audible, guys? Hello everyone, good afternoon to all. Am I audible, guys? Share the session, guys. Let's share the session. Good afternoon to all. Am I audible? Arpit Singh, good afternoon. Share the session, guys. Share the session, guys. Let's reach the session maximum. Vikas Kumar, good afternoon. Share the session, guys. Yes. Yes, it is audible, right? Suresh, good afternoon. Share the session, guys. Let's reach it to the maximum. Saloni, good afternoon. Let's few more members should be added. Share the session, guys. So make use of this marathon session. Share the session, guys. Balakrishnan, good afternoon. Right. So let me start the session here. So welcome to Unacademy. So welcome to GATE Conqueror. So welcome to marathon session for the BARC Part 3. So in this session we are going to start power electronics. So the next it is followed by the EMFT. So by Chaitanya sir. So and the next will be the engineering mathematics, and the next will be the power systems. So now before going into the session, so share the session, guys. So let's reach it to the maximum. The 16 is the minimum number. The 16 is the minimum number. So here we are going to solve more number of numericals. So and we are going to discuss the more number of concepts. So let's reach it to the maximum, so that you just share the link of this YouTube link. So this session. So share the link. So let's reach it to the maximum. So before going into the session, let me introduce myself. So I am Sathish Kumar Kesireddi. So I got AR 18 and AR 286. So I had a 10+ years of teaching experience. So I did my MTech from NIT Tirchi. I was ex-BHL employee. So I was expertise in the subjects of power electronics, power systems, and network theory. So now, if you use the code as KSK10, you will get the 10% discount on Unacademy Plus subscription. So here we have the Plus and iconic subscriptions. In Plus subscription, we have live classes. So crash courses, weekly tests, and doubt solving sessions will be there. So the classes will be held in both English and Hindi. So here the personal coach will be allotted. So he will be guide you like anything to reach your goal. So the study booster sessions will be conducted here. So personalized test analysis will be there. Study planner sessions will be conducted. So dedicated doubt clear instructor will be there. So here preparatory study material also will be available. So in the iconic subscription. So this is the fee for the Plus and iconic subscriptions. So if you use the code as KSK10, you will get the 10% discount. So this is the for 12 months, 18 months, 24 months. So after 10 months discount, so it will be the amount for the 12 months. So 18 months and so this will be amount for the 24 months. So if you cannot able to bear the total amount, you can opt for the no cost EMI also. So this is for iconic subscription. This is also for plus 12 months, 18 months and 24 months here. So this is the amount after 10% of discount. So if you use the code as KSK10, you will get the 10% discount here. So for the 12 months, 18 months and 24 months. So here you can opt for the no cost EMI if you cannot able to bear the total amount. So this is the Unacademy ask a doubt. So in this you can ask doubts at any time. So the doubts are not limited here. So the video solutions can be provided. So both English and Hindi. So here unlimited doubts you can ask here. So receive exact matches for your questions. So and get the assistance with your homework. Get the assistance for your homework. So obtain the instant and accurate solutions of the lakhs of questions. So this is a new batch for GATE and ESE 2022. So this is Crack and Arohan batch. So which is start from the September 1st. So which is GATE 22 and GATE 2023. So this is for ECE. So again Crack and Arohan batch. So this is the target batch for ESE prelims. So this is the target batch for the ESE prelims for ECE branch. So these are all starting from the September 1st. So if you use the code as KSK10, you will get the 10% discount. So these are the special classes. The special classes are nothing but the free classes which are available in the Unacademy Learner app. So there you can interact with there will be interactive live classes. There you can interact with your educator. So you can ask any doubt. So while watching the session. So here the polls for the learner will be created. So if you can answer that polls, so you will get better understanding. So raise a hand option will be there in case of special classes. So never miss a class, you will get notified. So whenever the class scheduled by your favorite faculty or favorite educator. So lecture notes can be downloaded here. So anywhere, anytime. So you can watch the lecture anywhere, anytime because it's an online platform. So now let us start the session with the easiest question to the toughest questions now. So in the previous session also we have seen some of the power electronics questions in the marathon 1. So now let us continue the power electronics in this session also. So now let me take the first question here. So let me take the first question here. T. Bhaskar, good afternoon. Shakti Charan, good afternoon. Share the session, guys. Still 23 is the smallest number. Share the session, guys. So let's start the session. So here, so the first question will be simple, right? Because so it is a power diode. The power diode is given. So rate of the fall of the current has given, which is the di by dt. So what is the stored charge? We need to find the QRR. We need to find the QRR. So now, so what is the QRR expression? So if you remember the QRR expression, that is sufficient. So in this case, so the QRR will be depends on reverse recovery characteristics. So which will derived from this waveform. So which are derived from this waveform, right? So which are derived from this waveform. So QRR will be so half into di by dt into so TRR square divided by 1 plus S. TRR square divided by 1 plus S. So this is the expression for that. So if you assume that the S is smaller than 1, so because the nowhere softness factor is mentioned in the options, so that we should neglect the so S equal to 1. So because it is less than 1, so that the QRR will be half into di by dt into TRR square. So TR square, here the TR is given. So which option is correct here? So which option is correct here? Is anyone is answered? So Arpit Singh, you are right, it will be the B. So half into di by dt into TR square. So the reverse recovery charge is proportional to the rate of decay of current. So and square of the reverse recovery time. So square of the reverse recovery time. So shall we see the next question? So shall we see the next question? So now let us see the next question here. So what is the question here? So consider the following statements with regard to the power diode. So with regard to the power diode, consider the following statements. So in all the statements, so which of the above statement is correct? So we should find, we have to find that, so which of the statement is correct in this? So which statement is correct? Can anyone answer? Can anyone answer here? So this is the second question of the power electronics in this session. So in this session, this is the second question here. So can anyone answer for this? So can we get answer from this? So observe here. So what is the answer for this? Can anyone answer? So be interactive, guys. Share the session. Definitely it is worth watching the marathon session. So you will find the different questions. So you will find the different questions with the different concepts in this session. So now, so let me start with the first option. So what is the first option here? The breakdown voltage is directly proportional to the doping density of the drift region. So what does it mean? What does it mean? Let us see. So for example, so it is a, let me take the PN diode. Let me take the PN diode. The N minus layer will be the drift layer. So it will be the N plus layer. So the PN diode will be like this. Here the anode terminal will be there and the cathode terminal will be there. Anode and cathode terminal will be there. So here the anode and cathode terminal is there. N minus layer is the drift region. So for example, if I reduce the doping density, what happens if I reduce the doping density? If I reduce the doping density, what happens? If I reduce the doping density, the width of the depletion layer increases. The width of the depletion layer increases. So the width of the depletion layer is increasing. If I draw the depletion layer in this, the width of the depletion layer increases. This width of the depletion layer increases. If width of the depletion layer increases, what happens? So if doping is reduced, means the width of the depletion layer increases. Width of the depletion layer is increases. If width of the depletion layer increases, what happens to the electric field intensity? Electric field intensity also increases. So if electric field intensity increases, what happens? So the barrier potential, the voltage, the breakdown voltage will also increases. The breakdown voltage will also increases. If doping density is reduced, means the breakdown voltage increases. The breakdown voltage increases. So but it is not proportional, right? So it is a wrong statement. So the first one is wrong statement because, so if I reduce the doping density, so the barrier potential increases. It is inversely proportional, not it is directly proportional. So the first statement is wrong. So let us see the second statement. Losses in the diode are less due to the conductivity modulation, of the drift region in the on state. So what does it mean? So the conductivity modulation is nothing but enhancement of the conductivity. Due to minority charge carrier injection. So in this, due to minority charge carrier injection in the n-minus layer, so which causes excess charge carriers in the n-minus layer, so which causes, if carrier concentration increases, what happens? The conductivity increases. That phenomena is called as conductivity modulation. So because of conductivity, what happens? So if conductance increases, what happens? Conductance increases, what happens? Resistivity reduces. If resistivity reduces, what happens to the resistance? Resistance also reduces. If resistance reduces, what happens? So the losses in the diode reduces. So the losses are less due to the conductivity modulation. This statement is correct. So conductivity in modulation is nothing but enhancement of the conductance. So increase of conductance. If I increase the conductance, so what happens? So the resistivity reduces. If resistivity reduces, the resistance also reduces. If resistance reduces, losses are minimum. So it is clear. The second statement is correct. So now let us see the third one. So if I use the vertically oriented structure, it supports more blocking voltage. Is it correct? So the vertical supportive structure will be used to increase the current carrying capability, not the blocking voltage. So if I use the vertical structure, what happens? The area of the current flowing through the device will increases. So due to that, the current carrying capacity increases, not the blocking voltage. So only the option 2 is correct. So option B is correct. Arpit Singh, it is not C. So the vertical oriented structure is used to support the maximum current rating, not to block the voltage. So to increase the blocking voltage, we need to introduce the n-minus layer. Shubham Kandwal, right? Yes, right. So it will be the option 2 is the correct option. Are you clear with this question or not? If you have any doubt, you can ask. So because 2 of the members are typed the wrong answer, if you have any doubt, you can ask. So don't get confused here. So be simple. It is simple. As simple as. So if I introduce the n-minus layer in between the P and N, so what happens? The depletion width will increase. If depletion width increases, what happens? The blocking voltage increases. So the n-minus layer is due to, for increasing the blocking voltage. But vertical structure, if I use the vertical structure, what happens? The current path through the vertical oriented structure will be, area will be more, so which causes, the maximum current capability will be increases. To increase the current capability, we will use the vertical structure. So for example, if I give to increase the current capability, it will be the correct option. So here the second one is the right. So losses is less due to conductivity modulation. So now let us see the next question. Note here that it is meant for, the vertical structure is meant for, to increase the current carrying capability. Still, if you have doubt, I will explain clearly. So why the vertical structure would be? Why the vertical structure will increase the current carrying capacity? So I will be here. So I will explain here. So for example, if I take the diode is like this. So here the P layer is there, and N layer is there, and N-minus layer is there. So the vertical structure is nothing but, the top terminals, the current passing terminals will be projected at the top end and bottom end. So here the anode is there and the cathode is there. Anode and cathode are there. So what happens if the current flows through the device? So it flows into the entire device. So due to that what happens? The area of the current path increases. The area in which current is flowing increases. If area increases, what happens? So resistance reduces. If resistance reduces, what happens? For the same conduction losses, I can increase the current rating. So the reason behind the vertical oriented structure will be this. So don't get confused, guys. Now let us solve the next question. So let us solve the next question. Let us solve the next question, guys. So let us solve more questions in this session. More questions in this session. Be interactive. Shubham Kanwal, I think you are clear now. I think you are clear now. Even if you have doubt, you can ask. I think you are clear now. Yes. So let me solve the next question here. Let me solve the next question here. So directly, if you can, so remember the formula, you can apply but. So from the concept, it will be the very easy. So let me give from the concept. So let me take from the concept. So here, so the characteristics will be like this. Reverse recovery characteristics will be like this. So here the total time will be the TRR. So which is the reverse recovery time. So which is the reverse recovery time. So here this time will be divided into T4 and T5. But in this problem, nowhere softness factor has mentioned. So that we can neglect the softness factor. So we can take the total characteristics will be like this. So we can take the total characteristics in this format. So now T4 equal to TRR. So T4 equal to TRR. So if T4 equal TRR, so this will be the IRR. So that is maximum reverse recovery current. So that is maximum reverse recovery current. So now this will be the di by dt. This will be the di by dt. So di by dt equal to slope of that line will be IRR height divided by T4. So IRR divided by TRR. So TRR. So here if you know the IRR, you can find. So IRR equal to di by dt into TRR. So what is the di by dt? So di by dt is 30 ampere per microsecond. TRR is given as 3 microsecond. 30 into 3, which is the 90. So we have to multiply the di by dt into TRR. So 90. So now what we have to find? QRR. So charge also we need to find. So QRR is the integration of this current curve. So let me integrate this. So if I integrate this one, so I will get the QRR. I will get the QRR. So how I can integrate? I need to find the area. So how I can find the area? So height into half into base. Base is TRR. Height is the IRR. Height is the IRR. So from this I can find half into 90 into, so IRR is the 90, TRR is the, so TRR is the 3 microseconds. 3 microseconds. So it will be the, so 135 microcoulombs. It will be the 135 microcoulombs. It will be the 135 microcoulombs. If you derive from the concept, it will be easy, guys. Or else if you can use the direct formula also. So QRR equal to, so as we know that QRR equal to half into di by dt into TRR square. TRR square. This formula already we have seen. So even if you apply in this, you will get the same. You will get the same. So here, maximum try to follow for the conceptual approach so that it will be useful. Now let us solve the next question. Saloni option A is right option, right? Let us solve the next question. So now let us solve the next question. So let us increase the difficulty level slowly. So now what is the question here? So SCR is considered to be semi-controlled device. SCR is considered to be semi-controlled device. SCR is considered to be semi-controlled device. So because what is the reason? So which option is correct here? So which option is correct here? So SCR is semi-controlled device. SCR is semi-controlled device. The first option will be it can be turned off but not turned on. So that's a wrong option, right? So the second option will be it conducts during only the half cycle of alternating wave. So that's also wrong option. So it can be turned on but turned off with a gate pulse. So that will be wrong option. So it can be turned on only during so half cycle of alternating voltage waveform. So it can be turned off but not turned off with the gate pulse. It's right option, right? So SCR is a device. SCR is a device. So SCR is a device. So option C is the right option. So let us see why it is. So SCR is a device. So to turn on the SCR, it needs to satisfy the two conditions. So the first condition will be if SCR symbol will be like this. So the anode, cathode and gate terminal, if it is having anode, cathode and gate terminal, so what happens? When VAK is greater than 0, when VAK is greater than 0, it should be forward bias. So the additional condition also should satisfied. So we need to give the triggering pulse, gate pulse, gate pulse. So to turn on the SCR, the gate pulse is required. But to turn off the SCR, so even if I remove the gate pulse, the device won't turn off. So to turn off the SCR, the anode current, in ideal case, the anode current should be 0. In a practical case, the anode current should be less than holding current. The anode current should be less than holding current. So SCR is a semi-controlled device. Here we can control the turn on and we cannot control the turn off. So during turn off, so the anode current should be reduced to 0 or the less than holding current. So this is clear. So it cannot be turned off. It cannot be turned off. So let us see the next question. So this Snubber circuit used in the Thyristor. So what is the function of Snubber circuit? So what is Snubber circuit? So can anyone answer this? Kanan, hi sir. So hi. So now let us see the next question. So this Snubber circuit in the Thyristor is used for. So what for will use the Snubber circuit? So be interactive guys, be interactive. Definitely you will get the new concepts from this session. So be interactive. Yes, it is meant for the dV by dt protection. Saloni, you are right. So it is meant for the dV by dt protection. So this Snubber circuit is nothing but, which is connected in parallel with Thyristor. So a series combination of resistance and capacitance is connected in parallel with the Thyristor. So Snubber circuit is nothing but, a series combination of resistance and capacitance is connected in parallel with the Thyristor, which is used for the dV by dt protection. So dV by dt protection. So which is used for the dV by dt protection. So dV by dt protection. I think you are all clear. So now let us go to the next. So this one is easy question, right? So this Snubber circuit will be used for the dV by dt protection. So this is always asked in the most of the competitive exams also. So most frequently asked question. So now let us see this question. So try to find the answer for this question. Let me explain the question first. So understand the question first. So what is this? What they have given? So it is given as buck boost converter operating in continuous conduction mode, CCM. So the switch Q is operating at 25 kHz. The switching frequency is given as 25 kHz. Duty cycle is 0.4. Duty cycle is given as 0.4. And the output resistance, the load resistance, output resistance, RL or R0 is given as 10 ohms. So the diode and switches are ideal. So under steady state condition, find the input resistance. So tell me the answer guys. Try to find the answer for this question. So we need to find the input resistance of the buck boost converter. So these are all the specifications has given. So they have given switching frequency, duty cycle as well as output resistance. So we need to find the input resistance. So what will be the answer? Shubham Kanwal. Basically, a Snubber circuit is a combination of resistance and capacitance. But if they have used the inductance in series with that, so it will support the di by dt protection also. Di by dt protection also. But the main function of this Snubber circuit is, if both are mentioned, if you want to choose the one option, choose the dV by dt protection. I think you are clear. So 22.5. So yesterday we have discussed already. So by using the transformer approach we can solve. So that is DC transformer approach. What is that? So here let us take. So easily we can solve. Let us take the DC to DC transformer. So let us make a equivalent circuit of the DC to DC converter in the transformer equivalent circuit. So in transformer equivalent circuit, let me take the gain of the, so output gain will be the 1:m of D. So where m of D is output gain, m of D is output gain. So output gain is nothing but V0 by Vin, V0 by Vin, right? So output gain we have. So next, so it is Vs, here Vs is there. So Vs is there. So next, so in the load resistance is connected, which is the 10 ohms, which is the 10 ohms. Now we need to find the R in, we need to find the R in. So it is simple, if you understand this, it is simple. So what is the R in here? So R input, so for these problems, this is the easiest method. R in equal to R0 divided by m of D whole square, m of D whole square, m of D whole square. So what does it mean? So here we have shifted the R0 load resistance into the, so primary, the secondary, if the secondary resistance is shifted to the primary, so we need to divide it by the transformation ratio, which is divided by k square. So m of D whole square. So m of D is given as, so here D is given as 0.4. So if D is given as 0.4, so what would be the m of D? So m of D is nothing but voltage gain, voltage gain. So in case of buck boost converter, the voltage gain is V0 equal to Vin into D by 1 minus D. So let us find the D by 1 minus D. So which is nothing but 0.4 divided by 0.6. So 0.6. So now let me substitute in m of D. So this is the formula we need to use for the any of the converter you can find. By simply one single step in you can find. So how we can find? R0 divided by, that is R0 is 10 ohms divided by, so 0.4 by 0.6 whole square. So 0.4 by 0.6 whole square. 0.4 by 0.6 whole square. So we can find from this. We can find from this. So what is the answer here? So which is the 22.5, 22.5 ohms. 22.5 ohms. 22.5 ohms. So I think this method will be useful for everyone, right? So we can answer very quickly if you use this method. So the R input is R0 divided by m of D whole square. So any converter you can take, you can find easily. You can find easily. If you are comfortable with this question, let us forward to the next level. Saloni, it is not 22.9. Just check the answer once again. So it is 22.5. It is 22.5. It is 22.5. So now let us solve the next question. Let us solve the next question. Let us solve the next question. So what is this question here? So let me explain the question. So after that, try to solve the question. So it is a boost converter is given. So it is having the input voltage of, 440 volts, input voltage of 40 volts, and it is connected to the resistive network. So RL equal to, that is RL equal to R0 equal to, so which is given as 10 ohms. So which is given as 10 ohms. The value of inductance is 1 millihenry. So the value of inductance is 1 millihenry. And the equivalent resistance will be 0.1 ohm. So let me take the R is 0.1 ohm. So here the inductance has given, so with the internal resistance, so inductance has the internal resistance R and L. So the values has given. So in that case, the output gain is, if the output gain is 5 ohms, if the output gain is 5, so which is nothing but m of D, output gain is nothing but V0 by Vin, V0 by Vin. So then the input resistance is R in. Let us find the input resistance, guys. For this, let us find the input resistance. So let us find the input resistance. This is the question has given. So if I draw the circuit, it will be like this. So it is a buck converter, right? It is a boost converter, right? So the inductance on the source side. So this inductance has series resistance. This inductance has series resistance. So it is connected like this. It is connected like this. So this is the circuit has given. R0 is given as, so 10 ohms. and small r is given as 0.1 ohm, and L is given as 1 millihenry, and there is nowhere Vs and V naught has mentioned, but V naught by V in, input voltage, is given as 5. So try to write the answer for this. So try to find the answer for this. Try to find the answer for this. So try to find the answer for this. So if you follow my previous class, so in the marathon session, you will definitely find this very easily. Otherwise, it will take some time. It will take some time. So let us find. So how it will be, let us find. So here, if you observe here, so this circuit, if I draw the equivalent circuit, how it will be? So if I draw the equivalent circuit, it will be, so like this. So it has the RL, small r is there. So the input will be represented with the transformer model. Let the transformer model will be here. So and this will be like this. So output will be represented will be like this. So in the output we have the resistance R naught. So let us find the R in. So is it difficult, guys? Is it difficult? So I think this approach will be useful, very useful. So this approach will be very useful. So within seconds you can write the answer. If you know this concept, within seconds you can write the answer. So how we can find? So the small r is given as 0.1 ohm. The small r is given as 0.1 ohm. So R naught is given as 10 ohms. And this transformation ratio, that is V naught by V in, so is given as 1:5. 1:5. So V naught by V in equal to, so is given as 5. So it is simple basic transformer equivalent circuit we can find from this. So R naught equal to R in equal to R naught plus, so that is output resistance plus small r, so R naught divided by K square, that is M of D whole square. So plus small RL, plus small RL. So which is nothing but this value. So which is nothing but this value. Let us find 10 by 5 square. So 10 by 5 square. So plus 0.1. So it will be the 0.4 plus 0.1. So 0.5 ohms is the correct option. 0.5 ohms is the correct option. So 0.5 ohms is the correct option. So simple, guys, very simple. If any input resistance problem is came, so if you follow this concept, it will be very useful. So it will be very useful. So other than any method, this will be very useful. Or else it will take most time of the, so it will take more time. It will take more time. Or else it will take more time. Arpit Singh and Shivandan Kumar. So right, see it is the 0.5. So 0.5. So respond, guys. If you have any doubt till now, you can ask. So let us clarify here itself. So after that, we'll forward to the next question. So if you have any doubt, you can ask. If you have any doubt, you can ask. Clear? So now let us see the next question. So now let us see the next question. The answer will be 0.5 ohms. So now let us see the next question. So this will be the series resistance is 0.1 ohm here. So 1 millihenry inductance has given. So how to find the output voltage here? So can anyone answer for this question? So what is the question? Let me explain the question first. So again, it is a boost converter. Boost converter having the input voltage is 20 volts. So input voltage is given as Vs is given as 20 volts, right? So it is connected to the resistive network, resistive load. So it is connected to the resistive load. So with the inductance, the value of inductance in that circuit, so is given as 1 millihenry. So L is given as 1 millihenry, right? So series resistance of 0.1 ohm. So we have the series resistance small r as 0.1 ohm. 0.1 ohm. So if the duty cycle is 1, if duty cycle is given 1, so what will be the output voltage? So what is output voltage? So this is the question for ESE 2021. So this question was asked in the ESE 2021. So this question was asked in the ESE 2021. So we should consider the non-linearities also. So we should consider when you study the DC to DC converter, so you should consider the non-linearities also. So what is non-linearities in the sense? So we should consider the inductive resistance. So we should consider the switch on-state resistance. So like that we should consider the non-linearities also. So what is the answer for this? So what is the answer for this? Can anyone tell? So can anyone tell that what is the answer for this? Shivandan Kumar, A is right option. A is right option. So Molly Manikanta, just check once. So I will explain here. So here, so if you for the RL load, for the R and RL, if they have given R and RL, so you should follow that. So you should know the output voltage expression for that. So you should know the output voltage expression for that. So the output voltage expression would be, so the output voltage expression would be, it will be different for the, for example, so let me give the brief idea about the, so different for the different converters, what will be the output voltage. So that if the problem has changed to the buck converter, so boost converter or buck boost converter, so you must be able to answer that question. Let us see. So let us see. So here if you observe here, so V0 can be calculated from, so V0, if R and RL is given, so for the buck converter, the formula will be, so V0 by Vin equal to, or Vs equal to, so duty cycle into 1 by 1 plus small r divided by capital RL. So where small r is the, so inductive resistance, capital RL is the, so the load resistance. So for it is boost converter, if it is a boost converter, so it will be the, so V0 by Vs into, so D 1 by 1 minus D into 1 by 1 plus R by RL into 1 minus D whole square, So this is the formula for the boost converter. So if it is buck boost converter, so V0 by Vs equal to, so D by 1 minus D into 1 by 1 plus small r by capital RL into 1 minus D whole square. So for example, if I substitute the duty cycle as 1, so in the boost converter what happens? So in the boost converter, if I substitute so D equal to 1, what happens? So 1 minus D is 0. So it becomes 1 by infinite. So if you substitute here, so 1 minus D equal to 0. So it becomes 0. Something by 0, it will get the infinite. So So what happens here? So 1 by infinite will becomes the, so 1 by infinity will becomes the 0. So V0 will be 0. So for this problem, so if you don't know the formula, so it is difficult to find. So on any case, if they have given the R and RL, so R and RL, so you can find the output voltage from these formulas. So for the buck converter, this is the formula. So for the boost converter, it will be this. So for the buck boost, so the formula will be this one. So now let us solve the next question. So this is the question has given. So here what we have to find here. So a thyristor circuit is shown in the figure. So the latching current of the thyristor is 50 milliamperes. Latching current is given as 50 amperes. So we need to find the minimum width of the gate pulse to trigger the thyristor. So what will be the answer here? I think it is easiest question. So what will be the answer? So what will be the answer? So what will be the answer for this? So it is easiest question, right? So what will be the answer? We need to find the minimum gate pulse width required to trigger the Thyristor. Minimum gate pulse width required to the Thyristor. So yes, it is 4 milliseconds. So how it will be, we'll see here. So if the Thyristor is on here, if the Thyristor is an on condition here, so what happens? So the VL equal to VS. So where we know that VL equal to LDI by dt. LDI by dt. So here we need to find the time. We need to find the time. So the current has given as, 50 milliamperes. So if I substitute in this, so 50 milliamperes. So 50 milliamperes into L is given as, so L is given as 4 Henry. So L is given as 4 Henry. So divided by, so Vs is given as 50. So Vs is given as 50. So which is equal to 4 milliseconds. If I want to find the T, so it will be same. So it is easy question. It is easy question, guys. It is easy question. Let us solve the next question. Let us solve the next question. So it is 4 milliseconds. So option A is the right option. So let us solve the next question. So let us cover almost all the topics which are required for the BARC as well as GATE here. So now, so this is the question here. So what we have to find here? So if you observe here, so SCR having the turn on time of 5 microseconds. So the latching current has given, so latching current is given as 50 milliamperes, 50 milliamperes. Now, so the holding current is given as 40 milliamperes. So is triggering by the short duration of the pulse, is triggered by the short duration of pulse. So used in the circuit shown in the figure. So the minimum pulse width required to turn on the SCR. So what is the minimum pulse required to turn on the SCR? We need to find here. So how we can find? So how we can find? So if you observe here, so the current, so which is the minimum current required to turn on the SCR is latching current. So from that we can find the, time period of that pulse. Let us find. So let me take the, this circuit here. So let me bring this circuit here. So the current will be, let this current will be in the RL, it has two elements. It has two elements. So in the first element, it has a parallel combination of R, L and R. So let me take the I1 here, so I2 here. Let me take the I1 and I2 here. So the IL is the combination of I1 plus I2. So from that we can find. So IL is combination of I1 plus I2. It is a simple RL circuit. For an RL circuit, so what is the formula? So for an RL circuit, it will be the Vs by R into 1 minus e power minus t by tau. Right? Where tau equal to L by R. Tau equal to L by R. So by using this, so we can find the current in the RL circuit. So it is a combination of two currents. If I add that two currents from that, so I can find the T value. So now let us find the T value. So IL equal to 50 milliamperes. So IL equal to 50 milliamperes. So which is equal to, now let us find the current in the first path. So how I can find the current in the first path? So which is equal to Vs by R. So nothing but Vs is given as 100. So 100 divided by R. So R is 20 into 1 minus e power, so minus t by tau. So tau is nothing but L by R. So which is nothing but R by L. So which is 20 by 0.5. 20 by 0.5 Henry into T. Right? So into T. So plus the next current will be, it is simple resistance, right? It is a simple resistance. So when this switch is in closed condition, what happens? So 100 by 5K is the current. So 100 by 5K. 100 by 5K. So simplify this one. So this one, so we need to find the T value from this. If we need to find the T value, we need to find the T value from this. So which one is the correct option here? So T will be the 150 microseconds. So verify this answer. If you find the T from this, you will get the 150 microseconds. So it is easy problem. So before that only inductance has given. Now we have gone one more step. So here R, L is given and R is given. So T you will get the 150 microseconds. So 150 microseconds. So let us solve the next question. Let us solve the next question. So let me cover all the questions. Some of the questions may be the basic question, some of the questions may require more time. So but let me solve all the questions. Let me solve all the questions. Yes, B is the right answer. B is the right answer. Shivnathan Kumar, B is the right answer. So everybody is clear, so or else we need to find. I need to simplify this or else you can simplify. So it is simple, guys. So apply the natural logarithm and you can find the t value. So from this expression we need to find the t value. We need to find the t value. So the t is the minimum pulse width required to turn on the SCR. Minimum pulse width required to turn on the SCR. I think we are clear with this question. So let me go for next question. Can I go for next question? Everyone is clear? Arpit Singh. Yeah, right. So let us solve the next question. So what is this question? So understand this question. So what we have to find? So let me explain the question first. Try to find for this question. So it is as similar to the previous question, but so the parameter which we have to find is different. That's it. So the SCR in the circuit shown in the latching current will be the 40 milliamperes. The latching current has given as 40 milliamperes. So the latching current is given as 40 milliamperes and the gate pulse is of 50 microseconds. T has given which is 50 microseconds. So the gate pulse width also given here in this problem. So now let us find the R value. So the maximum value of R to ensure the successful firing of SCR. So we need to find the R value. So how we can find? So let us find the R value. So we know that IL equal to so 40 milliamperes, which is the summation of the I1 plus I2. So here also let me take I1 and I2. So let me take I1 and I2. The I1 current will be so again it will be the Vs by R into e power minus t by tau. So now let me take, so IL equal to 40 milliamperes, 40 into 10 power minus 3. So which is equal to, so Vs by R into e power 1 minus e power minus t by tau. So Vs is 100. So R value is 500, right? So R is given as 500 into 1 minus e power minus t by tau. So 1 minus e power minus t is the 50 microseconds. So 50 micro into, so R value is given as 500. R by L we need to take. So 500 divided by L is 200 millihenry. So 200 millihenry, right? So we got the expression. So now, so one more thing has added. So I2 will be the 100 by R. So it is simple, guys. We need to find the latching current. The latching current is the summation of, so here the latching current is the summation of, so I1 plus I2. Latching current is the summation of I1 plus I2. So their I1 current will be the Vs by R into 1 minus e power minus t by tau. So by using that one we can find the I1. So I2 will be the, so Vs by R2. So this R value we need to find. So remaining all values are there, so except R value. So let us find the R value. So the R value should be, so you should be 60 ohms. So try to find the R value. Tell me the answer, guys. So try to find the R value. Simplify this expression. This is simple mathematical expression. So in BARC, so we have the calculator also. So you can simplify this expression very easily. So let us find the R value. Shivanandan Kumar, check once again. Check the answer, guys. Find the R value and tell me the answer. So be interactive, guys. Let us solve more questions. If you are interactive, I will solve more questions. Check the answer. So tell me the answer, guys. Waiting for your answer. If we are clear with this, let us go forward. Yes, Harpreet Singh, it is 60 ohms. Please verify the answer. Six 6060 is the right answer. Just check once again. Shivanandan Kumar. So what about remaining people? So tell me the answer, guys. Be interactive. Vikas Kumar, are you there? Tell me the answer, guys. So it is simple calculation part. $6060 ohms is the right answer. Okay, let us solve the next question, guys. Let us solve the next question. So let us solve the next question. Let us solve the next question. Let us cover all the topics. So what is the given here? The voltage across the current is the voltage and current has given. So the voltage waveform and current waveform has given in this. The voltage waveform and the current waveform has given. So voltage waveform and current waveform has given. So from this, what we have to find? So we have to find that. So the energy dissipated during the turn-on transition. So during a turn-on transition is shown in the figure. This is the characteristics for the turn-on transition. We need to find the energy. So we need to find the energy dissipation. How we can find? Let us see. So how we can find? Let us see. So let us see. So let's move on to the next problem. Saloni, you are right. 60 ohms is the right answer. Check once again, Shivanand Kumar. So let us solve the next problem. Let us solve more problem, guys, so that the volume of your problem will be more. So you will get the huge collection of in your volume. So let us solve the more questions. So here it was given as, so the voltage waveform is given here. So and the current waveform is also given here. So across switch during the turn-on transition. So why we are saying that it is a turn-on transition? So because during turn-on transition, the voltage is going to be decreasing and the current is going to be increasing. So current is going to be increasing and the voltage is decreasing here. So if the voltage is decreasing and current is increasing, so we can tell that it is a turn-on transition. By observing the waveform itself, so we can tell that, so it is a turn-on transition. So if you observe that, so let me find the So energy during the on state, so energy dissipated during the on state. So let me divide it into two periods. So E1 and E2, E1 and E2. So during the E1 period, let me find the during E1 period, that is T1 period. So what is the, from this period to this period, so from this period to this period, let us find the E1. Let us find the E1. How we can find the E1? So E1 is nothing but, so E1 equal to, so let us find the E1. E1 equal to, so integration of 0 to T1, 0 to T1. So from 0 to T1, so the voltage value is Vs. Let it be the Vs. So the voltage value is Vs. Let it be the Vs. And the current is increasing. Current is increasing. So what is the value here? So this value is 150 amperes. So 50 plus 100, this value will be the 150 amperes. Now let us find, so Vs is given as, so Vs is 600 volts. So Vs is 600 into, so Vs is 600, it is constant and it is increasing. So 150 into, so 150 into, so it is a line equation, T by T1 into dt, into dt. So now let us find the E1 here. So now let us find the E1 here. So what is the E1 here? 600 into 150, so into integration of T by T1 is T square by 2 T1, T square by 2 T1. If I substitute 0 to T1, so what is the value of this one? So it will be the 600 into 150, 600 into 150 into T1 by 2, T1 by 2, T1 by 2. So what is this value? 600 into 150 into T1 by 2. So the T1 value is given as 1 microsecond. Let us substitute the 1 microsecond. So which is the 600 into 150. So divided by 2. So into T1 is 1 microseconds. So into T1 is 1 micro. So it will be the, so 45 millijoules. It will be the 45 millijoules. 45 millijoules. During the E1 period, during the T1 period, so we got the E1 as 45 millijoules. 45 millijoules. Now let us find for the T2 period. Now let us find for the T2 period. So if I find for the T2 period, so how it will be, let us see. If I find for the T2 period, so then the T2 period, so the current is constant and the voltage is in the decreasing slope. So now let us write the expression for T2. Let us write the expression for T2. So here E2 equal to, so integration of voltage is in the decreasing nature. So how we can write the expression? So Vs into 1 minus T by T2. So because we are considering the T2 period here, so T2 into, so I is the 100 amperes. So I is the 100 amperes into 100. So which is constant. So Vs is 600. Let me substitute that. 600 into, right? 600 into, so T2 is 1 microsecond here. 600 into 100. 600 into, so we need to take the 100 here because, so it is 100 here. So 100. So into, so 1 minus T by 2. If I integrate that, I will get the T minus T square by 2 T2. So the limits are 0 to D2. So it will become the T2 by 2. So I will get the 600 into 100 into 1 microsecond divided by 2. So which is the 30 millijoules. Which is the 30 millijoules. So which is 30 millijoules. Now the answer is summation of E1 and E2. Now the answer is summation of E1 and E2. So which is the 45 plus 30. So which is the 75 millijoules. 75 millijoules. So the answer will be the 75 millijoules. So the answer for this, 75 millijoules. So if you understand this, so this type of questions you can solve easily. So whichever be the question you can find easily. So here we need to divide the periods, and in each period we need to find the, so we need to find the voltage equation and current equation, and from that we need to find the energy or power. So energy or power. So the answer is 75 millijoules. Right. So Arpit Singh, 75 millijoules is right answer. Shivanandan Kumar, so good, it is right answer. Saloni, 75 millijoules is the right answer, right. So now let us solve the next question. So what is this question? So it is simple question, right? It is simple question. So what is this? So a structure obtained by lightly doped N minus region between the layers of, so PN junction, so then PN diode is obtained, the structure is effective in. So here, so what is the question here? It is simple question. So already we have seen this. Indirectly we have seen this answer also. So we have the P and N layer, in between. If I place the N minus layer, so what happens if I place the N minus layer? So I will get the PIN diode. So I will get the PIN diode. So which is nothing but power diode. We will get the power diode. We will get the power diode. So if I got the power diode, this structure will be effective in. So what for we are introducing the N minus layer? They are asking about, so what for we are introducing the N minus layer? So the first one is it making support the large reverse blocking voltage. So the first option itself correct. So it is to make the, so it is to block the large reverse voltage. The N minus layer will introduce in the pin layer, pin diode, so to make the, to block the large reverse voltage. So the option A is the correct option. So the option A is the correct option. So in this, the option A is the correct option. Yeah, right. So Vikas Kumar, option A is the right option. So let us see the next question. So it is simple, guys. So if I introduce the N minus layer, the depletion width increases. If depletion width increases, reverse block down, so the reverse blocking voltage increases. So this is also simple question, right? So what is this question? The conductivity modulation phenomena is absent in. The conductivity modulation phenomena is absent in. So in which it will be absent? So let us find. So here the power diode is there, SCR is there, power MOSFET is there, and BJT is there. So what is conductivity modulation? If you know the conductivity modulation, what is conductivity modulation? Then you know the answer very clear, in the clear manner. So I think everyone knows the answer. Everyone knows the answer for this. So option C is the right option. Option C is the right option, right? Right. So why? Because so we should know the reason also here. For example, if I take the power diode, so it will be like this. So Pn minus and P layer. So if I take an SCR, it will be the PNPN structure. PNPN structure, right? PNPN structure. So if I use the BJT, so it will be the N minus, so NPN structure, N minus and P and N sections will be there. So it will be the NPN structure, right? So it will be the NPN structure. So if you take the MOSFET, so the complete structure will be the N layer. The complete structure will be the N layer. So the bottom layer will be the N plus. So here N minus will be there. So here the P layer is there, and here the N plus layer will be there. So if you observe the conduction path, so in this there is a possibility of minority charge carrier injection. Because of excess charge carriers, the conductivity increases. So here also there is a possibility of, if N minus layer will be introduced here, so there is a possibility of increasing the excess charge carriers, so that here also we can increase the conductivity by using the conductivity modulation. So here also what happens? There will be the injection of minority charge carriers in the N minus layer, so which causes so increase in the conductivity, so which is conductivity modulation. But in MOSFET, what happens? If the conduction takes place, the current flows in this direction. Here imaginary N layer will be formed, so in all the N layers it will be formed. So there is no possibility of injecting the minority charge carriers. It is a majority charge carrier device. So that the conductivity modulation is absent in MOSFET. So let us see the next question. So Triac can be categorized as. So let us solve more questions, guys. Be interactive. Let us solve more questions. So Triac can be categorized as. So which option is correct option? So the Triac can be categorized as. Which option is correct option? So respond, guys. Which option is the correct option? So in all this, which option is correct option? So let us solve easy questions as well as difficult questions also. So this is the easy question. This belongs to the easy question. So Triac can be categorized as. So as we know that Triac is minority charge carrier device. So minority carrier device. Triac is minority carrier device. So these two options A and C are the correct options here. So now at this stage, so it is a bipolar voltage blocking. So it can block both the voltages. So it is a bidirectional device. So it can bidirectional device. But if you observe here, so Triac is semi-controlled device. Triac is semi-controlled device. So that option C is the correct option. So Arpit Singh, not the B. So option C is the correct option. Let me explain you. So Triac is nothing but, so it is the anti-parallel connection of the two SCRs. Anti-parallel connection of two SCRs. It can allow the current in both the directions, so that it is bidirectional. That is simple. So the current can allow in the bidirectional. So it can allow the current in the both the directions. It can allow the current in the both the directions. So because it's a combination of two SCRs, it can block the voltage in both the directions. It can block the voltage in both the directions. So it is operate in all the four quadrants. It is a bidirectional bipolar device. But it is a minority carrier device. It is a minority carrier device. The conduction is due to the minority carriers. So here in a conduction path, it has a P layer as well as N layer also. So it will be the minority carrier device. So and it is a semi-controlled device. Why? Because, so it is a semi-controlled device. Why? Because, so here we can control the turn on, but we cannot control the turn off here. So by removing the gate signal, so the Triac will not get turns off. The Triac will not get turns off. If both turn on and turn off can be controllable, so we can say that it is a fully controlled device. If only turn on or if only turn off can be controlled, so we can say that it is a semi-controlled device. So it is a semi-controlled device. Semi-controlled device. So let us solve the next question. So let us solve the next question. So let us solve the next question. So let us solve the next question, guys. Can anyone tell that what is this question here? Let us solve this question. What is this question? A pure inductor is connected to the single phase sinusoidal source through a diode. What is the conduction angle of the diode? So here we need to find the conduction angle of the diode. So understand this question. So here, so the diode is there. This diode is there. So which is connected to the pure inductance. Which is connected to the pure inductance. So through a sinusoidal source. Through a sinusoidal source. How much duration the diode will conduct? The question is how much duration the diode will conduct. So for example, if I take the resistive load, it will conduct for 180 degrees, that we know. So during positive half cycle only, the diode will get forward bias, it will be in the on condition. But when you connect the inductance here, what happens? So for example, if the diode is in on condition, what happens? So if the diode is in on condition, so the output voltage are VL equal to Vs. When diode is in on condition, so what happens? VL equal to Vs. VL equal to Vs. So where Vs is the source voltage, so which is the Vm sin omega t. Vm sin omega t. So Vm sin omega t. So if I want to find the current, so let me find from this. So VL equal to, we know that L di by dt. L di by dt. So from this we can find. So di equal to from this. So Vm sin omega t, Vm by L into sin omega t into dt. So if I integrate on both the sides, I will get the current. If I integrate on both the sides, I will get the current. So if I integrate in both the sides, so in between 0 to t, so I will get the current as Vm by integration of sin omega t is minus cos omega t divided by omega, so that Vm by omega L, so minus cos omega t, limits are 0 to t. So if I find the expression, it will be the Vm by omega L into 1 minus cos omega t. So if you know the current, so you can draw the waveform. From that we can define the, so in which duration, how much duration it is conducting. So let us draw the waveform also. So let us draw the waveform also. So now let me draw the input voltage waveform. Let me draw the input voltage waveform. So the input voltage waveform will be like this. The input voltage waveform will be like this, right? So now let it be the pi and 2 pi. So now let me draw the current waveform. Let me draw the current waveform. How the current waveform would be? So the current waveform will be when t equal to 0, when omega t equals 0, what happens? So 1 minus 1, so it will be 0. If I substitute omega t equals 0, cos 0 is 1, 1 minus 1 is 0. This point would be like this. If I substitute, so pi by 2, what happens? 1 minus cos pi by 2 will be the, so 1, so it is the Vm by omega L. So it will be the Vm by omega L. So if I substitute at omega equal to pi, so what happens? So 1 minus cos pi is 1 plus 1, it will be the 2, so it will be the 2 omega by L. So it will be the 2 omega by L. So the current is not 0. The current is not 0. For example, if it is resistive load, it will be 0 at pi. But if it is in that pure inductance is connected, so it is not, the current is not becomes to 0. So when it will be 0, so for example, if I substitute the pi value as 2 pi, omega t equal 2 pi, what happens? So 1 minus cos 2 pi is 0. So again it will be 0. So it will conduct for the period of 0 to 2 pi. 0 to 2 pi. So it will conduct for the period of 360 degrees. So it is simple, guys. So it is conduct for the period of 360 degrees. Now let us see. Now let us see the answer. So it will conduct for the period of 360 degrees. Answer is D. So answer is D. So it is also simple question. Answer is D. So if you know the expression, if you are able to find the current expression, that is sufficient. So from that we can conclude that how much time it is conducting. Kunwar, D is right answer. Arpit Singh, D is right answer. Right. So let us see the next question. Let us see the next question. Let us see the next question. So what is the answer for this? Can anyone tell that what is the answer for this? So read the question. So before that, there is a diode here. Now we have replaced the diode with the thyristor. So now we need to find the extinction angle here. So extinction angle is nothing but where the current is 0. So the angle at which the current equals 0 we need to find. So the angle at which the current equals 0 we need to find. So the extinction angle we need to find. So the angle in which duration the current is 0, so we need to find. How we can find? So what is the answer for this? So Vikas Kumar, we'll plan. So after completing the marathon session, so we will go to the, again we will go into the descriptive section. So in that section, so we'll go through all the concepts. So in comprehensive course, I will discuss all the concepts. Yes, the beta should be here. So the beta should be here. So 240 degrees. So how this answer came, let us see. So let the remaining people also follow this. So here, let me find the I value here. So how I can find the I value? So here also I equal to, so at firing angle alpha has given, so that means at 120 degrees, so the device will be into the on state. So at alpha equal to 120 degrees, we are giving the triggering pulse to the thyristor so that this thyristor will get turns on at alpha equal to 120 degrees. So what happens here? So I equal to, now let us find the I value. So when thyristor is in on condition, what happens? So Vm sin omega t equal to VL. So Vm sin omega t equal to, so VL. So now, so L di by dt, that is integration of Vm sin omega t into d omega t, so into dt. So Vm sin omega t into dt, the limit should be alpha by omega to the, so alpha by omega t to the t, so t. So here also we should consider for the period of alpha by omega to the t. So now let me find the generalized expression first. So the generalized expression would be like this. So it will be the Vm by omega L. So Vm by omega L So it is the extension of the previous question. Vm by omega L into cos alpha minus cos omega t. If I substitute from this, I will get this expression. So this is the current expression for this. So now if you know the current expression, so we can find the beta. So beta is nothing but where the current is going to be 0. So we need to find that current equal to 0. So the value of omega t equal to beta. Now let me make the I equal to 0 here. So if I make the I equal to 0, what happens in this expression? If I make the I equal to 0, so the cos alpha should be equal to cos omega t. Cos alpha equal to cos omega t. So omega t should be replaced by beta. Cos alpha equal to cos beta. When will be the cos alpha equal to cos beta? So when beta equal to 2 pi minus alpha. So beta equal to 2 pi minus alpha. So if I substitute beta value, if I want to find the beta value in this, so I need to take the 2 pi minus alpha. If beta equal to 2 pi minus alpha, that is 360 minus alpha, so I will get the extinction angle. So how I can find the extinction angle here? So the alpha is given as 120. So 360 minus 120 is 240. So which is the 240 degrees. So the value of beta will be the 240 degrees. So option A is the correct option. So now let us solve the next question. So right Vikas, 360 minus 120. So which is easy question, right? Now let us solve the next question. So this is simple question. So there is no mathematical calculations and all. So we need to apply some basic concepts. So here, so the IV characteristics of the power diode for large forward current is. So the IV characteristics of the power diode for the large forward current is. So how we can find the IV characteristics for the power diode? So let us obtain the power diode characteristics here. So VI characteristics here. So let me draw the VI characteristics here. So let me take V on x-axis, I on y-axis. So I on y-axis. So let me take V on x-axis and I on y-axis. So if I draw for the signal diode, so we know that the current will be in the exponential form. The current will increase in the exponential form, right? So here, so the forward current characteristics only we need to see. So now if I draw for the power diode, so for the power diode it is linear. So the forward current will be increases linear. So can anyone tell the reason behind that? So the option B is the right option. It is right. So it is right, guys. Option B is the right option. What is the reason behind this? So what is the reason behind this? Can anyone tell the reason? Guys? So why the forward characteristics of the power diode is linear? Why the forward characteristics of the power diode is linear? Can anyone tell? Saloni, B is the right option. Arpit Singh, B is the right option. So good. Can anyone tell the reason behind this? So what is the reason? Why it is linear? So why it is linear? Can anyone tell the reason? Why it is linear? Due to Hughes forward current. Is that right? If it is having the Hughes forward current, so why it will be the linear? N minus breakdown. So it is not due to the even N minus breakdown also. So observe here. So what is the reason behind if you compare the signal diode, the signal diode will be the P and N layers. The signal diode has the P and N layers. But in case of power diode, what happens? The N minus layer would be added. If N minus layer is added, what happens? So the system will be, because of N minus layer, because of n minus layer, so when compared to this, what happens? The charge concentration has reduced. So because of low charge concentration, which is very less when compared to the signal diode, so in this, because of drift layer, so what happens? Because of low charge concentration, so the charge concentration is proportional to the conductivity. So the conductivity also reduces. If conductivity also reduces, the resistance will be more. So basically because of n minus region, so the conductivity is less. Because of n minus region, the conductivity is less. So when compared to the signal diode, I am comparing with the signal diode here. So when compared to the signal diode, so the resistance is more. The resistance is more. It is more into the resistive nature. It is more into the resistive nature. So because of that, the IV characteristics, the relation between I and V is the linear. So because of this resistive nature, high resistive nature, when compared to the signal diode, so it follows the linear curve. It follows the linear curve. So now let us solve the next question. Let us solve the next question, guys. So let us solve the next question. So what is this question? So a single phase fully controlled bridge converter supplies and drawing a constant ripple free load current. So the load current is given as constant. If the firing angle alpha is given as 30 degrees, so what we have to find here? So here we need to find the input power factor, IPF, input power factor. So what is the input power factor? So input power factor, we need to find the input power factor here. How we can find the input power factor? So can anyone tell the answer here? Can anyone tell the answer? So here it was given as fully controlled bridge converter. So the firing angle is given as 30 degrees. So we need to find the input power factor. Simple, guys, very simple. So the basic formulas are needed. Let me give the basic formulas so that you can write answer very easily. So let me give the basic formulas here. For example, it is a single phase fully controlled converter. Let me take the single phase fully controlled converter here, single phase semi converter here. So if I find the output voltage, so how it will be? So it will be the 2 Vm by pi into cos alpha. For the constant current, it will be the 2 Vm by pi into cos alpha. So for the single phase semi converter, so it will be the Vm by pi into 1 plus cos alpha. So Vm by pi into 1 plus cos alpha. So if I find the IS source current, so the RMS value of the source current, here I will get the I naught, so which is the output current, constant current. So here in this, if I find that I naught into square root of pi minus alpha by pi. So if I find the IS1, that is fundamental source current. So that is fundamental source current. So the source current, fundamental source current formula will be 0.9 into I naught. So if I find the fundamental source current here, so what will be the thing here? So it will be the 0.9 into I naught into cos alpha by 2. So if I want to find the displacement power factor. Displacement power factor is nothing but fundamental power factor, so which is the angle between the fundamental voltage and fundamental current. So which is phi1. So if I find the displacement power factor, so cos phi1, so it will be the cos alpha here. So here it will be the cos alpha by 2. So now if I find the input power factor, distortion factor can be determined by the IS1 divided by IS. If you know the IS1 and IS, you can find the distortion factor. So now if I want to find the input power factor, so which is the product of distortion factor into displacement power factor. So input power factor is nothing but distortion factor into displacement power factor. If I want to find the THD, so the THD will be square root of 1 by, so if I take the distortion factor is G, 1 by G square minus 1. So these formulas are required because it is BARC exam, so that the questions will be, most of the questions will be easy here. So from these basic concepts they can ask the questions here. They can ask the questions. So let us solve this question. Let us solve this question. Let us solve this question. From that concepts, let us solve this question. Here what we have to find? What we have to find? So here it is given a single phase fully controlled converter, so that we need to take the single phase full converter circuit, right? So we need to find the input power factor. So the input power factor is equal to, so input power factor equal to distortion factor into displacement power factor. Displacement power factor. In a fully controlled converter, the displacement power factor is cos alpha, right? So in a distortion factor will be the IS1 divided by IS. So IS1 is the 0.9 I0. So 0.9 I0 divided by, so I0 into cos alpha, which is the 0.9 cos alpha, 0.9 cos alpha. So the input power factor will be the 0.9 cos alpha. So from this we can find. So let me find the input power factor. So if you know that formulas, that is sufficient for the single phase full converter and single phase semi converter, so most of the problems can be solved. So now let us find. So 0.9 into cos alpha, cos 30. So 0.779, so which is equal to, so 0.9 into, simple direct formula, it will be the 0.9 into cos 30, so which is equal to 0.78. So the answer will be the B. The answer will be the B. Rajkumar, it is not 0.866. So it is not displacement power factor, it is input power factor. So input power factor is the product of distortion factor and displacement power factor. So displacement power factor and distortion factor we need to find. So after that we need to take the input power factor. So this is the IS1 by IS into cos alpha. So Manikanta, right, option B is the right option, right? So Arpit Singh, option B is the right answer. So let us solve the next question. So in a single phase fully controlled converter, so 230 volts 50 Hz source is operating. So a firing angle is given as 60 degrees. So the firing angle is 60 degrees. The load current is assumed to be constant, so which is at 10. So load current is given as constant, I0 equal to 10. I0 is 10 amperes, right? So due to high value of inductance, find the input displacement factor. So we need to find the input displacement factor we need to find. So input displacement factor and input power factor. So displacement power factor and input power factor. So we need to find the displacement power factor and input power factor. Displacement factor and input power factor. So tell me the answer, guys. We know the formulas now. So it is easy, we know the formulas now. So if you know the I0, we can find firing angle and I0. So I0 and alpha is given as 60 degrees. So it is easy now. So what is the displacement factor here? So cos alpha. So what is the input power factor? 0.9 cos alpha. Substitute in this and tell me the answer, guys. So it is cos alpha and it is 0.9 cos alpha. So okay, let me draw the waveform also. But for this question, waveform is not needed. So whenever it is needed, I will draw. If you go by the waveform approach, it will take more time. So we need to find the Fourier series expression. So from that we need to find here. So displacement factor is cos alpha, cos 60 is 0.5, right? Cos 60 is 0.5. So on 0.9 cos alpha will be the 0.9 into cos 60. So that is 0.9 into 0.5, which is the 0.45. So the option D is the right option, right? So displacement factor we can find from the cos alpha. Distortion factor for the full converter will be the 0.9 cos alpha. So let us solve the next question. Let us solve the next question. So let us solve the next question. Solve this question. So here it was given as, semi-converter. So it was given the semi-converter output. So the semi-converter output has given, so on the sinusoidal AC source voltage, I0 is given as 20 amperes. I0 is given as 20 amperes. RMS value of fundamental component of the current. So we need to find the IS1 here. We need to find the IS1 here. How we can find the IS1 here? So there are two methods are there. So because the waveform has given, from that also we can find. So here in this waveform, so what they have mentioned? Alpha they have mentioned. So this is the semi-converter output current waveform. So source current waveform. So this is the semi-converter source current waveform. So it will start from alpha, right? So alpha is given as 30 degrees. So what we have to find? We need to find IS1. So we need to find the IS1. How we can find? So find the IS1 value. So IS1 is nothing but fundamental component. So IS1 here is 0.9 into cos alpha by 2. So 0.9 into cos alpha by 2 into I0. So from this you can find. So how we got this expression? So if I write the Fourier series for this, so let me tell you how we got this expression also. So let us find the IS1 here. 0.9 into cos alpha by 2 into I0. 0.9 into cos alpha by 2 is the cos alpha by 2 cos 15 degrees into I0 is given as 20 amperes. So what is the answer, guys? So 0.9 cos 15 into 20, 17.38 amperes. 17.38 amperes. So how we got this expression? So we got this expression from the Fourier series expression. So now let me tell you how we got this expression also. Because here the waveform is there. Let me tell you how we got the expression. So in a lecture 2, if you observe in a lecture 2, so we have derived the Fourier series expression for this waveform. So what is the Fourier series expression? So to make this waveform into the known form, we need to shift it to the alpha by 2. So let this will be the alpha. So this Fourier series expression for this is sigma n equal to 135 to infinity. So directly by observing the waveform I can write, so which is the 4 I0 divided by n pi into cos n alpha by 2 into sin n omega t minus alpha by 2. So what is the fundamental component here? So when I substitute n equal to 1, so please refer the lecture 2, guys. So in lecture 2 we have derived the expression for this waveform also. So by graphical approach, by moving this waveform to the alpha by 2, so if it is alpha, by moving this waveform towards the alpha by 2, towards right side, toward left side, so what will be the, so it will get into the known form. So from that we can derive the Fourier series expression. So from this we can get the IS1 here. So IS1 here, it will be the 4 I0 by pi. So because it is a RMS value, so we will get the maximum value, so we should divide it by root 2. Into cos alpha by 2. So which is nothing but, so into cos alpha by 2. So which is nothing but 0.9 into I0 into cos alpha by 2. So this expression we got from the Fourier series expression, guys. So if you know the Fourier series expression, no need to remember the equations also. Directly you can write the expression. So directly you can write the expression if you know the waveform. So let us solve the next question. So let us solve the next question. Solve this question, guys. So what is this question? So it is a single phase semi-converter. So it is a single phase semi-converter. So it was single phase semi-converter operated at 230 volts, 50 H AC supply. So with the firing angle is 45 degrees, pi by 4. So cos firing angle alpha is given as pi by 4. So now Vs RMS is given as 230 volts. So what we have to find? So load of the converter is highly inductive and it is constant. So it is a constant load. So and the resistance is given as 17.675. So load current is ripple free. So what we have to find? So we need to find the RMS value of the freewheeling diode. RMS value of the freewheeling diode. So how we can find the RMS value of the freewheeling diode? So to find the RMS value, so we should know that. So how the freewheeling diode current nature will be. So let us draw. If I take the output voltage waveform of semi-converter, so it would be like this. Right? It would be like this. So semi-converter is nothing but it has two controllable devices and two uncontrollable devices, right? So it will be like this. So now, in which region freewheeling diode conducts? In between the 0 to alpha. So it is alpha, it is pi, and it is pi plus alpha, and it is 2 pi. So if you compare in between the 0 to 2 pi, if the load current is constant, if the load current is assumed as constant because it was ripple free, so which is I naught, so the freewheeling diode will flows in the duration of 0 to alpha, in between the pi to pi plus alpha, so in between the 2 pi to 2 pi plus alpha. So the freewheeling diode conducts in that durations. So during that time, the freewheeling diode current would be like this. So if I draw the freewheeling diode current, so it would be like this. So here the freewheeling diode current will be like this. So how I can find the RMS value for this? So RMS value is nothing but, so I need to take the 0 to alpha. If I take the period of pi, so for this waveform, so the IFD RMS value will be I naught into, so this peak value is I naught into square root of alpha divided by pi. So the RMS value should be, so I naught into square root of alpha divided by pi. So now let us find the freewheeling diode RMS value. So we should know that I naught value. So I naught value does not given anywhere. So first let me find the I naught value. How I can find the I naught value here? So I naught value here. So V naught by R. So it will be the V naught by R. So we don't know the V naught value. We should find the V naught value. So V naught equal to, so for a semi-converter it will be the Vm by pi into 1 plus cos alpha. So now let us find the V naught value. So how I can find the V naught value? So Vm, so here, so don't make a mistake here. So here it was given as RMS value of the source voltage. Let us find maximum value of the source voltage. So 230 into root 2. So which is the maximum value of the source voltage divided by pi into 1 plus cos alpha is nothing but, so cos alpha is nothing but, so 1 plus, so cos alpha we should find. 1 plus cos alpha we should find. So how we can find the, so 1 plus cos alpha. So alpha is given as 45 degrees. So So let us find this. So if I find this, I will get the 176.75. So 176.75 volts. So from this, let me find the I naught value. I naught equal to V naught by R, right? So if I put the V naught by R, so that is 176.75 divided by 17.675. So what is the value here? So it will be the 10 amperes. So I got the I naught as 10 amperes. If I know the I naught, I can find the RMS value of the freewheeling diode current. So now let me find the RMS value of the freewheeling diode current. So the RMS value of the freewheeling diode current, so would be the RMS value of the freewheeling diode would be I naught into, so that is 10 into square root of pi by 4 divided by pi, alpha divided by pi. So which is nothing but 5 amperes. So which is the 5 amperes. So the option is, the starting one is option C is the correct option. So option C is the correct option. So now let us find the, so what we have to find? So we need to find the RMS value of the source current here. RMS value of the source current. How we can find? So RMS value of the fundamental source current. So we have seen that in a semi-converter. So what is the RMS value of the source current? So the RMS value of the source current would be 0.9 into I naught into cos alpha by 2. In the previous problem we have derived. So let us substitute in this. Let us substitute in this. So 0.9 into I naught is 10 into cos 45 divided by 2. Cos 45 divided by 2. So what will be the answer here? So let us find the answer for this. So 0.9 into I naught is 10 amperes into cos 22.5. So it will be the 8.314. 8.3149. So it is nearer to the 8.66. Let us choose the, so option D as the correct option. Option D as the correct option. Yes, 5 amperes and 8.317. Wasim Basha, you are right. So be interactive, guys. If you have any doubt, you can ask in middle. So not in problems, in theory also, if you have any doubt, you can ask. So because it is a live session, so be most interactive, so that you can solve most of your doubts. So we can discuss most of your doubts in a clear manner. Yes. So for the first one, the option C is correct, and for the second one, option D is correct. Everyone is clear? If you are clear, let us go to the next problem. Let us see the next problem. If you are clear, let us see the next problem. So Manikanta, source inductance effect when it should be considered. So if you observe that, so the question here it is the source inductance effect when it should consider. So if you consider any practical energy source, so what is AC source here? So it may be the synchronous generator, right? It may be the synchronous generator. So the generator contains synchronous reactance in series with that. So all practical sources, all practical energy sources, AC sources will have the source inductance. We should consider the source inductance when it is go for the practical. So when you are designing for the practical application, you should or you must consider for the source inductance. You must consider the source inductance. So because energy source has the internal inductance, that is synchronous reactance, so we can call it as a synchronous reactance if it is a synchronous generator. So we should consider the source inductance, guys. But in this problem, they have neglected the source inductance. That's why we have not considered. How much breakdown voltage of freewheeling diode? So it depends on parameters. Breakdown voltage will depends on system. So will depends on application. How much load you are using. So what type of load we are using. So from that, so we should design that. So the maximum value of the breakdown voltage. So from that we will choose the practical diode, practical freewheeling diode. So it depends on system parameters. So in the circuit parameters, it depends on circuit parameters. So what is the value? It depends on inductance. So it depends on resistance of the load. So it depends on remaining devices also. So the device capability, the device breakdown voltage will be decided by the circuit parameters. So first we should calculate what is the maximum value of the breakdown voltage in the circuit. So from that, so we should take the safety factor as 2. So from that we should choose the practical device. So let us go for the next question. So let us solve this question. let us solve this question. This is the previous gate question. So, but it is a simple question, guys. Let us solve this question. You will get an idea, some idea about RLE load, how the RLE load problems can be solved. So, by solving this problem, you will get some idea. Because in 2 hours, we cannot solve all the problems, but we should cover all the models. So, we should cover all the models. So, let us solve this problem, guys. Let us solve this problem. So, let us solve this problem. So, what is the problem here? Let me explain what is the problem here. So, here, so it is a single phase controlled rectifier, single phase rectifier. So, single phase rectifier, so which is having the output voltage expression of this rectifier circuit, having the output voltage expression of V0 equal to, so V0 equal to, so Vm by 2 pi into 3 plus cos alpha, 3 plus cos alpha. So 3 plus cos alpha. So next, what they have given? So Vm is given as 80 pi. So the maximum voltage is given as 80 pi. So the maximum voltage is given as 80 pi. So now, so here the firing angle is given. The power delivered to the lossless battery is 1600 watts. The power delivered to the lossless battery is given as 1600 watts. So that is E into I0. The power delivered to the battery will be, so E into the current flowing through the battery. So let current flowing through the battery is I0. So let current flowing through the battery is I0. So let current flowing through the battery is I0. So E into I0 is the power rating of the battery. So which is given as, so 1600 watts. 1600 watts. Now what we have to find? So we need to find the firing angle. We need to find the firing angle alpha for this. Alpha for this. How we can find? How we can find? So if you observe here, if you know the V0 in this expression, so you can find the alpha. So because we know the Vm value, so we don't know the alpha value and V0 value. So right. So now let us find the V0 value. If you can able to find the V0 value, so I can find the alpha value. I can find the alpha value. How I can find the V0 value? So here V0 equal to, it is an RLE load. So it is an RLE load. So we should consider across resistance, voltage across resistance, and here the average voltage across inductance is 0. So that we will not consider, and we should consider the battery voltage also. Now, so the voltage across, so output will be the I0 into R plus E. I0 into R plus E. So now the voltage across inductance, the voltage across the RLE load will be the, so this one. So for this V0, so I0, we don't know the I0 value. Let us find the I0 value. How I can find the I0? So from this expression I can find the I0. So the E value is given as 80 volts. So 80 into I0 equal to 1600 watts. 1600 watts. So from this, let me find the I0 value. So let me find the I0 value. So it will be the, 20 amperes. So it will be the 20 amperes, right? So I0 will get the 20 amperes. So if I know the I0, I can find the V0 value. So here I0 is 20 amperes, 20 into 2. So R value is 2 and the battery voltage is 80. Battery voltage is 80. So 40 plus 80 is 120 volts. We got the V0 value. If I know the V0 value, I can easily find the alpha value. Let us find the alpha value here. So let us find the alpha value here. So Vm is given as 80 pi. Let me substitute in this. So V0 we got the 120. So 120 equal to 80 pi divided by so 2 pi. 80 pi divided by 2 pi. So into 3 plus cos alpha. 3 plus cos alpha. So 3 plus cos alpha. So how we can find here? So here pi and pi will get cancelled out. So this will be the 40 times and this will be the 3. So the cos alpha is equal to 0. When will be the cos alpha equal to 0? When firing angle alpha is equal to 90 degrees. When firing angle alpha equal to 90 degrees. So for this, so the alpha value will be the 90 degrees. So for this problem, alpha value will be the 90 degrees. 90 degrees. Yes, Harpreet Singh, you are right. Wasim Basha, 90 degrees is right answer. Shivanandan Kumar, 90 degrees right answer. So Manikanta, you are also right, right? Be interactive, guys. Be interact. So be interactive, guys. So that we can solve more problems. More problems. Let us solve more problems. In all difficulty levels, we are going to solve the problems. We are going to touch all the models. Now let us see the next problem. Let us see the next problem. So this problem is related to the DC to DC converter. So this problem is related to the DC to DC converter. So try to find for this value. So what we have to find here? So we need to find the output voltage here. We need to find the output voltage. Try to find the output voltage for this. So for this problem. So let me explain what is the problem. From that you can find. So here the two switches are there, S1 and S2, and S1 is, so in a total 0.5 milliseconds, for 0.2 milliseconds, S1 switch is in on condition. For the remaining period, for the remaining 0.3 milliseconds, so for remaining 0.3 milliseconds, S2 is in on condition. So remaining 0.3 milliseconds will be, so S2 is in on condition. So if S1 is on for the 0.2 millisecond, if S2 is on for the 0.3 millisecond, we need to find the output voltage here. So find the output voltage, guys. Find the output voltage. We need to find the output voltage here. So find the output voltage. So after this session, it is followed by the Chaitanya Reddy sir. So after this session, it will be followed by the Chaitanya Reddy sir. So now let us solve this problem. Now let us solve this problem. Let us solve this problem. Can anyone tell the answer? Can anyone tell the answer? So let me explain, guys. Let me explain. So here, if you observe here, so this DC to DC converters are operating in the steady state. So here, this point we should consider. So this DC to DC converter, we are assuming that all this analysis we are making that. So these DC to DC converters are operating at steady state. So if it is operating at steady state, if these are operating at steady state, so for example, in between the 0.2 milliseconds, so what I have did, so the average value of the inductance voltage will be 0. If I find the average value of the inductor voltage, it should be equal to 0. So which is called as volt-second balance. So volt-second balance. The volt-second balance is nothing but, so the average value of the inductor voltage is 0. Now let us find the inductor voltage for 0.2 milliseconds. So 0.2 milliseconds. For the period of the 0.3 milliseconds, let us find the inductor voltage. If I add the two inductor voltage, it must be equal to 0. Now, so for 0.2 milliseconds, what happens? The S1 switch is in on condition. When S1 is in on condition, so what is the voltage across inductance? So here input voltage is 10 volts. So let the output voltage is V0. So what is the voltage across this one? So this inductance voltage will be, Vs minus V0. Right? Vs minus V0. So VL equal to 10 minus V0. So during 0.3 milliseconds, what we are going to do? So here, so during 0.3 milliseconds, so we are turn off the S1. So we should turn on the S2. So if you turn on the S2, what happens? If I turn on the S2, what happens? If I turn off the S1, so the 5 volts is applying across the inductance. So which is nothing but, so VL equal to 5 minus V0. If you can able to find the VL, so for both the periods, that is sufficient to get this problem solution. So now let us find the solution of this problem. So as I said before, so during steady state, the inductor voltage should be equal to 0. That is, it should follow the volt-second balance. So that means, so VL 10 minus V0 into 0.2 milliseconds, 0.2 milliseconds, that is 0.2. So plus, so 5 minus V naught into 5 minus V naught into, so what is the thing here? So we should consider the 0.3 milliseconds. So 0.3 milli, which should be equal to 0, which should be equal to 0. So if I take milliseconds as common, it will cancel out. So 10 into 0.2 will be the 2, 2 minus 0.2 V naught, so equal to, so 5 into 0.3 is 1.5 minus, so 0.3 into V naught. So it should be equal to 0. So what is the V naught here? So V naught here, it will be the 7 volts. 7 volts. So V naught will be the 7 volts. So it is simple, guys. Sarpit Singh, 7 volts is the right answer. Good. Shivanandan Kumar, 7 volts is right answer. So the remaining problems will be solved in the next session. So this session will be followed by the Chaitanya Reddy sir within few minutes. Just wait, guys. So within few minutes sir will join. So the EMF classes will be going. So the next session will be the Chaitanya Reddy sir. So up to here, if you have any doubt, you can ask. Let us solve more problem, guys. More conceptual problems. Let me add the more conceptual problems. So the next session will be by the Chaitanya Reddy sir. Just wait for a few minutes. Just wait for a few minutes, sir will join.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
And battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and
Hello students, welcome back to the session. It was a wonderful session by Sathish sir. Just confirm the video and audio once. Good evening Ravi. Good evening. Just like the session here, like and share the session. We are very less likes. So like the session everyone, subscribe to the channel and share the session so that your friends also will join the EMF session. Yesterday we have done some questions. There's continuation part of that will be done today. Yes Ravi, good evening. Before we start the session, let me introduce myself. I'm GC Reddy. I have 12 plus years of teaching experience in teaching, guiding and mentoring GATE and ESE aspirants. I mentored around 1 lakh students. Subjects taken: electromagnetic field theory, communications and advanced communications. This is about our special classes that we run on app. Special classes are designed in such a way that you have maximum benefit once you access them. As you all know, I'll schedule advanced communications sessions in special classes very soon. In special classes, we have features like interactive live sessions, polls for the learners. See, this poll-like kind of a system is very interactive and it is very advantage for the student. He can learn more. And you can never miss a class once you make your notifications on. And we also provide you the lecture notes and you can access anytime and anywhere. This is about our Plus subscription and Iconic subscription. Plus subscription includes live classes, crash courses, weekly tests, doubt solving. Will be explained both in Hindi and English, rank improvement batch, and not only all this, if you take an Iconic subscription, Along with all the plus subscription features, you'll also get a personal coach for your guidance and also a personalized test analysis. Not only writing tests is important, also doing the analysis and working on it is also very important feature. So Iconic includes everything. You can use the code also to avail 10% discount on all this subscription. You use the code GCR10 to avail the same. You can have this plus subscription for 12 months, 18 months and 24 months. These are the subscription values: 32,450, 41,300 and 47,200. These are for Iconic subscription for 12 months, 18 months and 24 months. You can avail it for by value of 50,250 for 12 month subscription, and 64,500 for 18 month subscription, and 74,000 for 24 month subscription. You can also use the no cost EMI option so that you can avail it easily. This is after you apply the code. This is what you get. You'll get this subscriptions at a lesser value, both plus and Iconic subscriptions. These are the batches that are going on right now in Unacademy, which is Crack GATE 2022, Arohan GATE 2023. This is for GATE 2022 aspirants. This is for GATE 2023 aspirants. These are faculty who teach for the electrical branch, and you can see all the iconic faculty, all the legendary faculty are there, including God of Machines. K.N. Rao sir is also in this team. This for ECE, and here also you are not the less, all the very important faculty are here to guide you and to make you crack the exam. This target ESE prelims 2022. You know, ESE has some additional subjects, so these additional subjects are covered in these particular batches called target batches. That's for ECE and this is for electrical. This is offer alert. This is what excites me. You can buy a 6-month subscription and you get plus 3 months subscription free. That means for 6 month subscription value, you get 9 months of data. So 9 months of subscription is very, very good, and 9 months of subscription you can prepare any exam including GATE. So I feel this is a very good offer here. If you are seriously, if you want to crack the exam, then this is the best option to have. This bugs bounty. If at all you can find any bug in our educators lecture, you can just report the same to get the reward. This is where you can follow. This is where you can follow me on Unacademy app. And just a small technical glitch. Can you give me a 1 minute of time? I'll be just back. Okay.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy.
Okay, dear. I hope the voice and video are clear. Small technical adjustments. So I just took a 1 minute break. Okay, just confirm the video and audio. So you can download the app. You can use the code GCR10. You can also follow my lectures on the Unacademy app. You can press the notification button Everyone subscribe to the GATE Conqueror channel, and it's a part of EMFT. We've done some very interesting questions yesterday. Those who had missed out yesterday's session, please go to the recording. There will be continuation for that in today's class. Here it goes, the first question. Yesterday we had solved 20 questions. So just to keep track of this, this 5, okay? Fine. That's the first question for you. Good evening, Vikas. Good evening, Sairam, Vanilla, Ravi, Arpit. Good evening, everyone. That's the first question for you. In fact, very fast. The formula for differential volume in spherical coordinate system is we operate on 3 coordinate systems. Cartesian coordinate system, cylindrical coordinate system, and spherical coordinate system. What are the Cartesian coordinates? X, Y, Z. Cylindrical coordinates rho, phi, and Z. Spherical coordinates R, theta, and phi. If you want to evaluate the directions along x, y, z, it is AX, AY, AZ, arrow, A phi, AZ, AR, A theta, A phi. If you want to write the volume, you should be able to write the differential length. Tell me what is the differential length along X? Yes, option D. Very good, very good, very good. Vanilla, Vikas, Arpit, very good. I'm just trying to explain you how it actually works. What is differential length along X? Dx. Differential length along Y? Dy. Differential length along Z? dz. What is the volume here? Differential volume is dx, dy, dz. That's for Cartesian coordinate system, which are used to evaluate structures like cube. Next is cylindrical coordinate system. Length along rho, differential length along rho, d rho, differential length along z, dz. Can anyone tell me what is the differential length along phi? Differential length along phi. Differential length along phi. Anyone? Differential length along phi. Phi is an angle, rho is the radius, length of the arc formula is rho into phi. Differential length is rho into d phi. Differential volume in cylindrical coordinate system is rho d rho d phi dz. In spherical coordinate system, differential length along r is dr. R is the radius, theta is the angle, length of the arc is r theta. Differential length is r into d theta. Here it is rho into d phi, same as this, but rho is cylindrical coordinate. Rho equivalent in spherical coordinate is r sin theta. Therefore, this is rho into d phi, which is r sin theta d phi. Then what will be the differential volume in spherical coordinate system? Differential volume is r square sin theta dr d theta d phi. Therefore, option D is the answer. Very good, Rajdeep. Sanjay, Arpit, very good. Now you got differential volume in Cartesian, cylindrical and spherical. Can you tell me what is the significance of this? You might have known this, am I right? What is the significance of these values? Anyone? Share the session, dear everyone. फटाफट शेयर कर दो, लाइक भी करना है. Only 45 likes. एटलीस्ट मैराथन को 100 बनता है यार. In Cartesian coordinate system, how much you got dV? We got dV as dx, dy, dz. In cylindrical, we got dV as rho d phi, d rho dz. In spherical, we got it as r square sin theta dr d theta d phi. Am I right? Significance क्या है इसका? What is the significance of this? Nazma, good evening, dear. First time Unacademy platform. Nazma. What is the significance of these values? dV is a differential volume. If you integrate this, you should get volume of a cube. Let us see. Volume of the cube is integral of dV. Triple integration dx, dy, dz. X running from 0 to x, that is length. Y running from 0 to y, breadth. Z running from 0 to z, that is height. L into B into H. Integral of 1 dx, that's x. 0 to x is x. Integral 1 dy, y. Integral 1 dz, z. Volume of the cube, LBH. X into y into z. Now you tell me what is the volume of the cylinder? Share among everyone, dear. जल्दी से शेयर कर दो. Everyone. Volume of the cylinder is volume integral of dV. Is volume integral of dV, which is triple integral rho d rho d phi dz. What is volume of the cylinder? Yes, everyone, fast respond. Everyone respond. Rho is from 0 to rho. Phi is from 0 to 2 pi. Z is from 0 to h or 0 to L, length. H is the height of the cylinder or L is the length of the cylinder. Then you can take L or H. Integral rho square by 2, limit 0 to rho. Integral 1 d phi, limit 0 to 2 pi. Integral 1 dz, z 0 to h. Evaluate this. This is rho square by 2, into 2 pi into h. This is pi rho square h. Volume of the cylinder of radius rho and height h, which is pi rho square h. H is the height of the cylinder. Am I right? Next is for the sphere. Next is for the sphere. If you do the volume integration, V is volume integral of dV. What are you supposed to get? Triple integral r square sin theta dr d theta d phi. R is radius of the sphere. 0 to r. Theta is the co-altitude angle or the elevation angle. 0 to pi. Phi is the azimuthal angle. 0 to 2 pi. Integral of r square r cube by 3. 0 to r. Integral of sin theta minus cos theta 0 to pi, or cos theta pi to 0. Cos theta pi to 0. Integral of 1 d phi phi 0 to 2 pi. This is r cube by 3. Cos 0 is 1 minus cos pi. Cos 180 is minus 1. 1 minus of 1 is 1. 1 plus 1, 2. Into 2 pi. This gives you volume of the sphere of radius r 4 by 3 pi r cube. That is why understanding dV is very important. Got it? Very good. Now you tell me, do you got the significance or not? Next question. Very simple one. Unit of magnetic field intensity is. Answered here, everyone. Unit of magnetic field intensity is. Electric field intensity is potential difference by distance or force per unit charge. Unit of electric field is volt per meter or Newton per coulomb. Electric charge is given in coulomb. Okay? So volt per meter or Newton per coulomb. Magnetic field intensity is I by L formula. Unit ampere per meter. Unit is ampere per meter. Okay. Now, if you do comparative study, it is always easy for you. How? Voltage produces electric field. Voltage produces electric field. Therefore, unit of electric field intensity is volt per meter. Current produces magnetic field. Therefore, unit of magnetic field intensity is ampere per meter. Now, easy to remember. Electric field volt per meter, magnetic field ampere per meter. Am I right? Yes. Unit of magnetic dipole moment. Unit of magnetic dipole moment is ampere per meter square. Ampere per meter, ampere meter square, ampere meter square, ampere per meter cube. Unit of magnetic dipole moment is? Magnetic dipole moment, small m, is given as I into A. I is current through the magnetic dipole, A is the cross-sectional area. Unit is ampere meter square. Option C is the answer. Therefore, option C is the answer. Very good, very good, very good. Next question. Unit of surface current is? Unit of surface current is? What is the unit of surface current? Unit of surface current. There are three types of currents. Line current, given by I. This is the current that is flowing in a line. Surface current, given by K. This is a current that is flowing in a surface. Volume current, given by J. This is a current that is flowing in a volume. This is a current that is flowing in a volume, which is volume current. Now tell me the units. Line current, surface current and volume current. What is the unit of line current? What is the unit of line current? Line current is a current that is flowing in the line. It's given by ampere. Am I right? Line current is a current that is flowing in the line, given by ampere. Surface current is a current that is flowing in the surface, that is ampere per meter. Volume current is a current that flows in the volume, ampere per meter square. Something else also has ampere per meter square. What is that? Some other quantity is also having ampere per meter square. What is the quantity that has ampere per meter square? What is a term which has ampere per meter square? Tell me. Current density. Yes. Current density. Current density is a term that has the same unit. Ampere per meter square. Now I have a doubt. Vikas correct. Sirivanella correct. Is this current density and volume current are one and the same? I'll just demonstrate you. I need just normal pen, okay? With refill. The question is, yes, Basha, Rajdeep. Is current density and volume current are one and the same? Basha, Arpit, Vanilla. Volume current is having ampere per meter square. Ampere per meter square is supposed to be the unit of current density also. Then if that is the case, are they both same? Okay, now you see. The three types of current I am talking about are, can you see the pen? Okay. I'm trying to open this, okay? The current that is flowing in this refill, the current that is flowing in this refill is line current. The current that is flowing in this refill is line current, given in ampere. Shivanandan Kumar, Vikas, I'll give you clarity. This is line current. I'm keeping back this line current, okay? I kept the line current back. Now you take a knife. Now you take a knife and cut this. You take a knife and cut this. What happens? It opens up, am I right? It opens up. The current that is flowing on this surface is surface current. The current that flows on this surface is surface current. Okay. Now if I open this, there is a gap here, gap. Fill the gap with the current. Fill the gap with the current and close it. The current that is inside this pen is volume current. The current which is inside the pen is volume current. And if this volume current wants to come out from this, it will come out as this, the line current across this area. Line current ampere across this area, meter square, ampere per meter square. Therefore, the volume current and current density both are one and the same, no change. Got it? What was my question? Unit of surface current is, unit of surface current, very simple, ampere per meter. Options is the answer. Is that clear? Next question. Unit of surface charge density is, unit of surface charge density is, the unit of surface charge density is Vikas, Arpit. Any doubts? Charges are of 4 types. Charge at a given point called as point charge. The point charge can be a positive charge or negative charge. Charge that is flowing in a line. The total length is L. Total charge is Q. Then this line is supposed to carry uniform line charge density, rho L. Point charge is given by Coulomb. Line charge or uniform line charge density is total charge by total length, unit Coulomb per meter. If you consider a surface carrying a charge Q, having a total surface area S, and the surface is supposed to have uniform surface charge density rho S, which is Q by S, Coulomb per meter square. Coulomb per meter square. And if we consider a volume which is carrying a charge Q, having a total volume V, then this volume is supposed to have volume charge density rho V, which is total charge by total volume, Coulomb per meter cube. Point charge in Coulomb, line charge Coulomb per meter, surface charge Coulomb per meter square, volume charge Coulomb per meter cube. What it has is surface charge density, Coulomb per meter square. Option B is the answer. Is that clear? Next. Unit of electric dipole moment is unit of electric dipole moment is when you have two charges plus Q and minus Q. When you have two charges of equal magnitude and opposite polarity separated by distance d, it forms an electric dipole. It forms an electric dipole, and every electric dipole carries some dipole moment, which is magnitude of any one of the charge into the distance between them. Q into d, unit Coulomb meter. Therefore, option B is the answer. Is that clear? Yes. Next question. The nature of the medium to allow electric field is given by permittivity, permeability, electric susceptibility, magnetic susceptibility. The nature of the medium to allow electric field is given by permittivity. Permittivity is a property of the medium to allow electric field. Permeability is a property of the medium to allow magnetic field. Electric susceptibility is sensitivity of the dielectric magnetic field. The nature of the medium to allow electric field is given by permittivity. Option A is the answer. The value of dash is 1 less than relative permittivity. The value of dash is 1 less than relative permittivity. Is it the case? Buffering. Is it still buffering? Magnetic susceptibility is given by chi-m. Magnetic dipole moment is given by m. Electric susceptibility is given by chi-e. Electric dipole moment is given by P. Magnetic dipole moment, M is I into A, ampere meter square. Electric dipole moment P is Q into D. Coulomb meter. Magnetic susceptibility chi-m is related to mu r by, how mu r and chi-m are related? Mu r is equal to 1 plus chi-m. How chi is related to epsilon r? Epsilon r is equal to 1 plus chi-e. The value of dash is just 1 less than epsilon r, relative permittivity, which is electric susceptibility. Okay. The following have same units. The following have same units. IKJ, line current, ampere, surface current, ampere per meter, volume current, ampere per meter square. They are different units, am I right? Ideal differential current elements, ideal KDS JDV. This is ampere meter. K is surface current, ampere per meter into meter square, which is ampere meter. JDV, J is volume current, ampere per meter square into meter cube, which is ampere meter again. They all have same units. Rho L, Rho S, Rho V. Rho L is coulomb per meter, Rho S is coulomb per meter square, Rho V is coulomb per meter cube. They also do not have same unit. So option B is your answer. The following have same units. The following have same units. Rho S, D and P. P is polarization here. Rho S, coulomb per meter square. Electric flux density, electric flux per unit surface area, coulomb per meter square. P, polarization, dipole moment per unit volume, coulomb meter per meter cube, coulomb per meter square. Yes, they all have same units. Rho S, D and P has same units. Rho S, E and K. Rho S, coulomb per meter square. E, electric field, volt per meter. K, surface current, ampere per meter. They have different units. Rho S, surface charge density, coulomb per meter square. E, electric field intensity, volt per meter. H, magnetic field intensity, ampere per meter. They also have different units. H, K and M. H, magnetic field intensity, ampere per meter. K, surface current, ampere per meter. M, magnetizability. Magnetizability is magnetic dipole moment per unit volume. Magnetic dipole moment is I into A, ampere meter square per meter cube. This is ampere per meter. They two all have same unit. 1 and 4. Option D is your answer. Therefore, 1 and 4, option D is your answer. Next question. Next question. For magnetostatic fields, ideal is equivalent to KDS is equivalent to JDV. Is it true? Ideal is equal to KDS is equal to JDV. Ideal. Ampere meter, KDS, ampere meter, JDV, ampere meter, all have same unit, they are all equivalent. 31 true. Force between two current element is given by force between two current element is given by force between two current elements. If you take two current elements, this current element 1, this is element 1 and this is element 2, in which current I1 is flowing, in this current I2 is flowing, this is DL1, this is DL2, the radial distance between the elements is R. Then the force between these two current elements is given by Ampere's force law. Is given by Ampere's force law. Option B is the answer. Clear? Very good, yeah. Please keep sharing. Keep sharing the class. Keep sharing the class. If distance between two loops L1 and L2 carrying currents I1 and I2 is R, then force between the element is, then force between the elements is directly proportional to the distance between the loops, directly proportional to the product of currents, inversely proportional to the distance between the loops, inversely proportional to the square of distance between the loops. Which of the combinations are correct? Which of the combinations are correct? Force between two current elements, as I told you, force between two current elements is given by Ampere's force law. According to Ampere's force law, force between two current elements is mu naught I1 I2 by 2 pi R. So force between two current elements is directly proportional to the product of currents, is inversely proportional to the distance between them. Directly proportional to the distance between the loops? No. Directly proportional to product of currents? True. Inversely proportional to the distance between the loops? True. Inversely proportional to square of distance between the loops? False. Because force between two current elements is given by F is mu naught I1 I2 by 2 pi R. Next. J is equal to dou D by dou T. Represents which of the following? Conduction current density, convection current density, and displacement current density. Vanilla. J is equal to dou D by dou T represent displacement current density. Option C is the answer. The following current density depends on velocity of charged particles. The following current density depends on velocity of charged particles. The following current density depends on velocity of charged particles. Which of these current density depends on velocity of charged particles? Conduction current density J is equal to sigma E depends on conductivity of the material. Convection current density J is equal to rho VU depends on velocity of charged particles. Displacement current density J is equal to dou D by dou T depends on time varying fields. Depends on time varying fields. Which of these depends on velocity of charged particles? J is equal to rho VU. Convection current density depends on velocity of charged particles. Option B is the answer. Clear? Now do this, dear. Do this, dear. Consider a finite line carrying uniform line charge density. Consider a finite line carrying uniform line charge density rho L is equal to 5 coulomb per meter, making angles alpha 1 is equal to 30 degrees, alpha 2 is equal to 60 degrees. Electric field intensity at distant point or a radial distance of 10 meter is solve it, solve it. What's the answer? Arpit, Vikas, Vanilla, Basha. What's the answer here? Electric field intensity at a distant point P at a distance of rho due to a finite line carrying uniform line charge density rho L is given by E is equal to rho L by 4 pi epsilon naught rho sin alpha 1 minus sin alpha 2 into A rho plus cos alpha 2 minus cos alpha 1 into A phi. Rho L by 4 pi epsilon naught rho sin alpha 1 minus sin alpha 2 A rho plus cos alpha 2 minus cos alpha 1 A phi. Substitute now. Remember this formula. Very, very, very important question. Electric field intensity at radial distance due to finite line. After substitution, now rho L is given as 5 coulomb per meter. 5 by 4 pi epsilon naught. Rho is given as 10 meter. Sin alpha 1, 30 degrees, sin 30. Sin 30, 1 by 2. Minus sin 60. Root 3 by 2. Into A rho. Plus cos alpha 2, cos 60 1 by 2 minus cos 30 root 3 by 2 of A phi. If you solve this, this is 5 by 40. That's 1 by 8. 1 by 8 pi epsilon naught of 1 by 2 minus root 3 by 2 A rho plus 1 by 2 minus root 3 by 2 A phi. Therefore, option A is the answer. Very, very important question. It's a very important question, okay? Any doubts? Come on, dear, everyone, share the session, dear. Share the session. Share the session, like the session, dear. At least 100 likes बनता है यार. 100 लाइक तो बनता है मैराथन में, है ना? Next question. Do this, dear. Do this. Do this. Consider an infinite line. Consider an infinite line carrying a uniform line charge density of rho L is equal to 5 coulomb per meter. Find E, electric field intensity at a radial distance of 10 meter. At this point, I want E. This is an infinite line. What is the formula for electric field intensity for infinite line? An infinite line is carrying uniform line charge density rho L. At radial distance 10 meter, I want electric field intensity. What is the formula here? Electric field intensity due to infinite line carrying uniform line charge density rho L at a distant point rho is rho L by 2 pi epsilon naught rho into A rho. Substituting rho L is 5 coulomb per meter by 2 pi epsilon naught into 10 into A rho. 5 by 20 is 1 by 4. 1 by 4 pi epsilon naught A rho. What is 1 by 4 pi epsilon naught value? 9 into 10 power 9 into A rho. Yes, Arpit. Yes. 9 into 10 power 9 arrow. 1 by 4 pi epsilon naught. How to solve this? 1 by 4 pi epsilon naught is 1 by 4 pi epsilon naught. 10 power minus 9 by 36 pi. Pi cancels. 9 will move up. 9 into 10 power 9. It's 9 into 10 power 9. Okay. Next one. One more important question. समझ में आ रहा ना? थोड़ा सा डिफिकल्टी बढ़ा रहा हूं मैं. जैसे आपको सब्जेक्ट समझ में आएगा, थोड़ा सा डिफिकल्टी लेवल बढ़ाना चाहिए, है ना? We need to increase the difficulty level slightly. Consider a finite line carrying a current of 4.33 amp. Consider a finite line carrying a current of 4.33 amp, sorry. Of length as shown in the figure. Length is shown. This is having 5 meter length. This finite line is having 5 meter length. The magnetic field at a radial distance at a point P, at this point P, at this radial distance, is asking what is the magnetic field. Magnetic field intensity at a radial distance due to finite line. Of course, this is B. Solve this, 38. Vikas, Arpit, Basha, 38 question. Magnetic field intensity at a radial point P due to a finite line carrying current I is given by H is equal to I by 4 pi rho cos alpha 1 plus cos alpha 2 of A phi. Cos alpha 1 plus cos alpha 2 of A phi. Now this fellow is making equilateral triangle. Alpha 1 is 60 degrees. Alpha 2 is also 60 degrees. Substituting H is equal to I. I is 4.33 by 4 pi rho. Cos alpha 1, cos 60, 1 by 2 plus cos alpha 2, 1 by 2. 1 by 2 plus 1 by 2. That's 1 into A phi. Therefore, H is 4.33 by 4 pi rho into A phi. Now you need to find that rho. Find the rho value and substitute. Find this rho value and substitute. If distance is 5, this half distance is 2.5. Applying Pythagoras theorem, hypotenuse square 5 square 25 is side square rho square plus side square 2.5 whole square. 25 minus 6.25 is rho square. Rho square is 18.75. Rho is under root of 18.75, which is 4.33. Clear? Alternatively, you can also apply tan 60. Tan 60 is equal to rho by 2.5. Tan 60 is root 3. 1.732 into 2.5. That's rho, which will be 4.33. Arpit, is it clear? What is that I by 2 pi rho? I'm not able to get Arpit. I by 2 pi. I'm not sure because I'm not able to read that what you're writing. You keep it in the comment section, later on we'll discuss, okay? This is special case under Bayard-Savart law, special case. Finite line at radial distance. Alpha 1 plus alpha 2 you'll get. Okay? Next. A semi-infinite line carrying current of semi-infinite line carrying current of 20 ampere from 0 to infinity on positive x-axis. This fellow is carrying a current of 20 ampere. The magnetic field at radial distance of 5 meter. At 5 meter radial distance is asking find magnetic field intensity. Magnetic field intensity at 5 meter radial distance is, how to find? Please solve here. 39A. For semi-infinite line, what is the formula, Arpit? For semi-infinite line, what is the formula? For semi-infinite line, H is I by 4 pi rho A phi. 20 by 4 pi rho is 5 into A phi. 1 by pi A phi. 1 by pi A phi. Option A is the answer. An infinite line is carrying a current of 10 amp. It's for infinite line. An infinite line is carrying a current of 10 amp. Along the z-axis, magnetic field at radial distance of 5 meters is for infinite line. For infinite line, H is equal to I by 2 pi rho A phi. This 10 by 2 pi rho is 5 meter into A phi. 1 by pi A phi. It is 1 by pi A phi. 48th question, option A is the answer. Very good, Arpit. (41) Solve this. If Fe is the electric force, Fm is the magnetic force, according to Lorentz force equation, total force is Fe plus Fm. Electric force Fe is Q into E, magnetic force is Q into U cross B. It can be written as F is equal to QE plus Q into U cross B. Total force F is equal to Q into E plus U cross B. Therefore, total force at any point on the total force on a charged particle in the presence of electric field and magnetic field is given by Lorentz force equation, which is F is equal to Fe plus Fm. Option C is the answer. Next question. A charge of plus q coulomb is enclosed in a closed surface S. Then the flux lines dash the surface. Then the flux lines dash the surface. A charge of plus q coulombs is enclosed in a closed surface, yes, then the flux lines will dash the surface. As you know, positive charge, source of electric field, the flux lines will leave like this. Our flux lines will move radially outwards. So what is happening to the surface? They are leaving the surface. If you have a negative charge, the flux lines will enter the surface. Got it? Yes. Very good, Siri, Vikash, Patra, Basha. Very good. A Gaussian surface is one which is dashed with respect to charge distribution. A Gaussian surface is one which is dashed with respect to charge distribution. What's the answer here? Anandi Meena. Symmetric. A Gaussian surface is one which is symmetric with respect to charge distribution. Can you tell me what is a Gaussian surface for point charges? What is a Gaussian surface for point charges? Yes, Bhaskar, good evening. Sphere, Rahul, very good. A Gaussian surface for point charge is a sphere. Sphere is a Gaussian surface for a point charge. For line charge, what is the Gaussian surface? For line charge, what is the Gaussian surface? Very good. Rahul, very good. Patra, Vikas, very good. For line charge, what is the Gaussian surface? Cylinder. Cylinder is a Gaussian surface. A Gaussian surface is one which is symmetric with respect to charge distribution. Option B is the answer. Divergence theorem relates dash and dash. Divergence theorem relates dash and dash. Divergence theorem relates dash and dash. Rahul, say, very good. Fast response. Divergence theorem. According to divergence theorem, closed surface integral of some vector A dot ds is volume integral of del dot A dv. This is called divergence theorem. This is called divergence theorem. Can anyone tell me what is the physical interpretation for this? What is the physical significance for this? What is the physical significance for this equation? If you consider A is a source, then del dot A is a divergence of the source. How to understand this is, if you consider a closed surface, like this, and A is the source, let be light energy, and if I place the light on this surface, the amount of light, the energy A that I placed on the surface is equal to the amount of light that is spread, divergence in the volume. If I keep more number of lights, I'll get more light. I'm right. General phenomena, I'm right. Divergence theorem is also telling you the same thing. The amount of energy that you keep on the surface is equal to the amount of light that is spread, or the amount of energy that is spread in that volume. Is that clear? Is this concept clear, dear? Everyone, any doubts? So the amount of energy, the amount of light that I keep on this surface is equal to the amount of light that is spread in this volume. That is nothing but divergence theorem. It gives you relation between closed surface and volume. Option C is the answer. Is that clear? Next. Go for this. Go for this question. A cylinder of radius 5 meter. A cylinder of radius 5 meter is considered, it is kept in vacuum condition. Inside the cylinder it is vacuum condition. The flux cut by the cylinder is yes. Yes, it is closed from top and bottom. Yes. A cylinder of radius 5 meter is considered, it is kept in vacuum condition. Inside the cylinder, the flux cut by the cylinder is, according to Gauss law, the amount of flux cut by any closed surface is equal to the charge enclosed by the surface. Psi is equal to charge enclosed. This is Gauss law in true form. According to Gauss law in true form, the amount of flux cut by any closed surface is equal to the charge enclosed by the surface. But this cylinder is kept in vacuum. Therefore, the amount of charge enclosed here is 0. Therefore, flux is also 0. So, from Gauss law, we can say that option C is the answer. Next. Electric potential is defined as work done per dash. Electric potential is defined as work done per dash. Electric potential defined as work done per unit charge. Question number 46. Option C is the answer. Equation for EMF is electromotive force. Equation for EMF is we know work done is equal to force into displacement. Work done is equal to force into displacement. Force is vector quantity. Displacement is vector quantity. Work done is a dot product of both. I'm right. Therefore, work done, force dot displacement. What does it mean? F is nothing but Q into E, electric force. Force on the charge particle Q in the presence of electric field E. If you expand this, work done W is equal to Q into E dot L. This is work done. What is this? Work done on the charge particle Q in the presence of electric field E in order to displace it by a value of L is called work done. What is work done here? It is the work done in displacing the charge Q which is present in electric field E by a value of L. If you consider smaller displacement, you have smaller work done. dW is equal to QE dot DL. From this, work done is Q into integral of E dot DL. If I assume that an external agent is doing the work, then you get a negative sign. Minus Q into line integral of E dot DL. This is work done. What is electric potential? Work done per unit charge. Therefore, electric potential V is minus line integral of E dot DL. which is called electromotive force. This electric potential is nothing but the electromotive force. For VEMF is equal to minus line integral of E dot dl. Clear? Is the derivation clear, everyone? Solve this. Gauss law in true form is read the question carefully and answer, okay? What is Gauss law in true form? Rahul, according to the statement of Gauss law, the amount of flux cut by any closed surface is equal to the charge enclosed by the surface. Therefore, psi E is equal to charge enclosed. This is called Gauss law in true form. By definition. Now, if you write psi E, electric flux density is electric flux per unit surface area, unit coulomb per meter square. If you consider a small surface area ds, the flux associated with it is d psi E. Then d psi E is d into ds. This is called scalar notation. All these values are in scalars. If you write in vector notation, as you know, electric flux is scalar. D dot ds. This is vector notation. Then flux psi E is closed surface integral of d dot ds. Then flux psi E is closed surface integral of d dot ds. Okay. Psi E is surface integral of d dot ds. Psi E is surface integral of d dot ds. We'll solve this. Now, what about the charge enclosed? Now, what is the definition of Gauss law? Gauss law states that the amount of flux cut by any closed surface is equal to the charge enclosed by the closed surface. What is the charge enclosed by the closed surface? Closed surface is nothing but volume. So, you need to write charge enclosed in terms of volume. If you take volume charge density is total charge by total volume, Q by V, coulomb per meter cube. If you consider a small volume dV, the charge enclosed by it is dq. Then dq is equal to rho v dv. Q is volume integral of rho v dv. Therefore, charge enclosed is volume integral of rho v dv. Now, if you apply this, if you equate LHS and RHS, closed surface integral of d dot ds is volume integral of rho v dv. This is called integral form of Gauss law. Integral form of Gauss law. Now if you apply divergence theorem on LHS, closed surface integral of d dot ds is volume integral of del dot d dv is volume integral of rho v dv. Removing the volume integral on both sides, del dot d is equal to rho v. This is called point form or differential form of Gauss law. So what is the first one? Integral form. Second, differential form. Third, true form. What is the question I had asked? Gauss law in true form is, Gauss law in true form is psi A is equal to charge enclosed. Option C is the answer. Got it? Very good, Sai Teja, very good. Next one. MMF is not valid for regions where. Solve this, dear. Very important question. What's the answer? MMF, magnetomotive force, is not valid for regions where. What's the answer, dear? MMF stands for magnetomotive force, scalar magnetic potential, VM. Units, ampere turn. Just like electromotive force, EMF, which is voltage given in volts, MMF is current given in ampere turn. Just like we can write E is minus del V, relation between E and V, we can also write H is equal to minus del Vm. From conservative property of electrostatic field, we know del cross E is equal to 0. That is del cross minus del V is equal to 0. What is this? Curl of gradient of any scalar. Curl of a gradient of any scalar is 0. Vector identity. It satisfies vector identity. Therefore, E is equal to minus del V is always true. Whereas, you know from Ampere's law, del cross H is equal to J. If you substitute H is minus del Vm, del cross minus del Vm is equal to J. But you know from vector identity, del cross minus del Vm, curl of gradient of any scalar must be 0. According to vector identity, curl of gradient of any scalar must be 0. But according to Ampere's law, I am getting it as J. That means what? That means what? That means what here? H is equal to minus del Vm is true if and only if J is equal to 0. H is equal to minus del Vm is true if and only if J is equal to 0. It is not true always, but H is equal to minus del Vm is true if and only if J is 0, or Vm is defined only when J is 0. When is J 0? J is sigma E. J is 0 when sigma is 0. Therefore, Vm is defined when sigma is 0. Wherever sigma is 0, like in perfect dielectrics, insulators, vacuum, in all these regions, scalar magnetic potential Vm is defined. Wherever there is a small conductivity, Vm is not valid. What is the question? MMF Vm is not valid in what regions? Wherever there is sigma, it is not valid. Wherever sigma is not equal to 0, wherever there is a value of sigma, MMF fails. This is called failure of MMF. This is called failure of MMF. Failure of MMF. Magnetomotive force cannot be defined in the regions where there is sigma conductivity. Therefore, this property is called failure of MMF. So, MMF is not valid when wherever there is sigma, wherever sigma is not equal to 0. Option B is the answer. Is that clear? Is that clear, everyone? Just let me know. Very important concept. That's a very, very important concept. Any doubts here? Please let me know. Any doubts? Yes, Bhaskar. This is all the explanation. MMF is not valid for regions where MMF is not valid, wherever you have sigma not equal to 0, wherever you have sigma not equal to 0, MMF will fail. Is that clear? Bhaskar, you want me to explain again this concept 49? Question number 49, you want me to explain again? See, there are two types of force, magnetomotive force and electromotive force. Magnetomotive force is current given as ampere turn. Electromotive force is voltage given by volts. Magnetomotive force is given by scalar magnetic potential, which is also called as MMF. Now, as we have E is equal to minus del V, relation between E and V, and from conservative property of electrostatic field, del cross E is equal to 0. Substituting E here, del cross minus del V is equal to 0. What is this? Curl of gradient of any scalar, which is 0. Curl of gradient of any scalar is 0 is a vector identity. Every vector and scalar must obey vector identity. Del cross minus del VM, del cross minus del V is 0. Yes. At substituted E is minus del V, it is obeying vector identity. As it is obeying vector identity, I can say E can be defined always, or E value is always true, or V is defined everywhere. Electromotive force V is defined everywhere. Whereas, just like we define E is minus del V, we can also show H is minus del Vm. And from Ampere's law, del cross H is J. If you substitute the value of H here, we get del cross minus del Vm is J. But according to vector identity, del cross minus del Vm must be 0. If it obeys, it must obey vector identity. That means this value must be 0. When this value will be 0, then only H is equal to minus del Vm is true. Am I right? Because del cross H is J. H is minus del Vm, I substituted del cross minus del Vm, I am getting J. But according to vector identity, I should get 0. When it is 0, it is obeying vector identity. That means what? Vm can be defined only when J is 0. When is J 0? When sigma is 0. So Vm can be defined only when sigma is 0. Where sigma is 0, Vm can be defined. Where Vm cannot be defined, where sigma is not equal to 0. MMF Vm is not valid in the regions where sigma is not equal to 0. Vm, scalar magnetic potential, is only valid when sigma is 0. In perfect dielectrics, in vacuum, in insulators, only in these regions Vm exists. Wherever there is a fine conductivity, Vm will fail. This concept is called failure of MMF. Is that clear, Bhaskar? Yes, dear, everyone, is that clear? Equation that represents conservative property of electric field is equation that represents conservative property of electric field is according to conservative property of electric field, the curl of E is 0 or orientation of electric field is 0. Electrostatic field move in straight line. This is called the conservative nature of electric field. Not only that, we know the standard relation between V and E. V is equal to minus line integral of E dot dl. When V is 0, you get closed loop integral of E dot dl is 0. When you close the loop, this is open loop, when you close the loop, V will become 0. Equipotential surface. Whenever V is 0, you know work done per unit charge is potential. When potential is 0, work done is 0. Work done is 0 means what? Work done in moving a charge in the presence of electrostatic field is 0. This property is called conservative property of electrostatic field. So in this equation, which equation represents the conservative nature of electric field? Closed loop integral of E dot dl is 0, implies V is 0 or work done is 0. Work done in moving the charge in the presence of electric field is 0. This is called conservative nature of electric field. Clear? This is called the conservative nature of electric field. Any doubts here? Okay. Work done. Work done is represented by the formula. Work done is represented by the formula. Yes, Manikandan. Thank you. Work done is Q into V. V is minus integral E dot dl moving from initial point to final point. Therefore, work done is minus Q into line integral of initial point to final point E dot dl. Work done is minus Q into integral initial point to final point E dot dl. Option A is the answer. Is it clear? Yes, Vanilla. Next. The unit of MMF is unit of MMF is electromotive force. VEMF is voltage. Magnetomotive force VM is current. This given in volts. This is given in ampere turn. Ampere turn. Option B is the answer. Yes, yes, yes. Very good, very good, very good. Poisson's equation for electric fields is Poisson's equation for electric field is for electric field from Gauss law, del dot D is equal to rho V. Gauss law in differential form. D is equal to epsilon naught T, relation between D and E. Substituting del dot epsilon naught T is rho V, implies del dot E is rho V by epsilon naught. From relation between E and V, E is minus del V. Substituting del dot minus del V is rho V by epsilon naught. For a homogeneous medium, if you do del dot del, it will become del square, minus will come on to RHS. Del square V is minus rho V by epsilon naught. This is called Poisson's equation for electric fields. Option B is the answer. Therefore, option B is the answer. Manikanta. Which problem, dear, again? This one. Tell me the problem number, 53 or 52? Which problem, dear? Yes. Answer B again. Yes. Yes. Okay. If H is equal to XAX plus YAY plus ZAZ, then the value of J is, according to Ampere's law, del cross H is equal to J, implies J is del cross H. Del cross H is AX, AY, AZ, dou by dou X, dou by dou Y, dou by dou Z, X, Y, Z. AX of derivative of this is 0, this is 0, minus AY of derivative of these quantities are 0, plus AZ of these quantities are 0. You get a null vector. But anyways, magnitudes are given. Magnitude of it is 0. Clear? Yes. With this, we will close this particular session of EMF, and it will be continued by Hari sir. Hari sir will take up some very important questions today in mathematics. So they had selected some very important questions. You share among everyone, like the session, share the session, and share to the maximum, because mathematics will be useful for all the branches. You can share among all the branches. It's not like only EC or EEE. You can share among all the branches so that your other counterpart, your friends, can be benefited by this particular session. Anyways, it's a YouTube session. Everyone can access it very easily. Share among all your contacts so that most of the people will be benefited. And you got some very important questions to come in mathematics. There's a layover time of 2 minutes. Sir will try to continue after 2 minutes. Thank you all, dear.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
And battle it out with a test.
To bring out the best in you,
Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with a test.
To bring out the best in you,
Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your
Hello everyone, good evening all. Is audio video both are clear? Please reply. Is audio video clear? Good evening everyone. Yes. Okay. Yeah, in this session we are going to see a very beautiful conceptual questions from all the chapters, and we are going to cover all the topics in detail, right? Before going to start the session, let me introduce myself. I'm Haribabu Ande, having 5 years of teaching experience in GATE, and my MTech is in power systems. Before joining MTech itself, I started teaching engineering maths and aptitude. After that, I took controls also. You can use my code HARIMATH to get 10% off on Unacademy plus subscription, right? Yes, these are the 2 subscriptions that are there in Unacademy plus, in which we are going to have live classes, crash courses, weekly test, doubt solving for English and Hindi batch. At the same time, Iconic is also there, which is having all the features that are there in Plus. Along with that, we are going to have personal coach, study planner, study materials and all, right? Next. Yeah, these are the pricing plans for Plus for 12 months, 18 months and 24 months. You can use my code HARIMATH to get 10% off. So that these are the prices, right? These are the pricing plans for Iconic for 12 months, 18 months and 24 months. Here also you can use the code to get 10% off, right? Next, these are the new initiative by Unacademy. Unacademy Ask It Out. You can ask any time, at any time, any number of times you can ask any question from Hindi and English languages also, okay? And you are going to get assistance for homework also. This is a very good initiative. And there are new batches for GATE 2022 and 2023 and for ESE 2022 and ESE 2023 for both electrical and ECE. For both electrical and ECE, the new batch started from September 1st. Yeah, these are the special classes and its features. Special classes are the live interactive sessions which are available in Unacademy app for free. And in this live sessions, polls will be there. The educator is going to ask the questions in the form of polls. You need to respond to that polls to get the better understanding of the concept. Raise a hand is also there. That means whenever you are having any doubt, you can raise, right? And never miss a class. You are going to get the notification if you follow any educator. All the time you are going to get the notification when the educator is coming to live. And also you can download lecture notes also. Of course, at any time, anywhere you can watch these special classes. Yeah, Bucks Bounty. If any learner found any inappropriate content in Unacademy, then the learner is going to get rewarded, right? Yeah. So let's move on to the session. This is the first question. Try to solve this one here. Try to solve this one. Yeah, good evening. Good evening, Burning. Good evening, Saloni. Good evening here. Try to solve this question. I hope this question is visible, I think. I hope this question is visible. Yeah. This is a very basic question. If we know the properties of one of the beautiful property of eigenvalues, then we can solve this problem just like that. We can solve this problem just like that. Try to solve this here. Try to solve this. Try to solve this question. What is this question? All the 4 entries of 2 by 2 matrix of P, P11, P12, P21, P22 are non-zero. Okay, that means the elements are non-zero and one of its eigenvalue is 0. One of its eigenvalue is 0. Okay, so then which one of the following statement is true? The only condition that is given here is, one of the eigenvalue is 0. One of the eigenvalue is 0. One of the eigenvalue is 0. Okay, this is what the condition. Along with the condition, if we know the simple property, one of the simple property of eigenvalues, then we can answer this question. We can answer this question. Now try to solve this one. What is the answer? What is the answer for this one? Come on guys, answer the question. I have given clue already. One of the property, by using the one of the property and by using this clue, one of the eigenvalue is 0, we can able to solve this question easily. What is that? If you try to see here, all the options are having P11 into P22 minus P12 into P21. P12 into P21. What it represents for a matrix P? What this term represents? P11, P22 minus P12, P21. What it represents? Any replies? P11, P22 minus P12, P21. This is nothing but determinant. This is nothing but determinant of P, right? Determinant of P. Now try to find the property which is having relation with determinant of matrix and eigenvalues. What is the property? What is the property? Any answers? Yes, C is correct. C is correct. Yeah, so what is the property here? The property is the product of eigenvalues is equals to the product of eigenvalues should be equals to determinant of matrix. Determinant of matrix, right? So if you try to see here, if one of the eigenvalue is 0, then what about the product of eigenvalues? First of all, how many eigenvalues this matrix is going to have? As it is 2 by 2 matrix, it is going to have 2 eigenvalues. So let me write those 2 eigenvalues as lambda 1 and lambda 2. Okay, as we are having property of product, lambda 1 into lambda 2 is equals to determinant of the matrix, right? Yes. So we know already one of the eigenvalue is 0, that means the product is going to be 0, right? So product is going to be 0, that means determinant is equals to 0. What is the determinant value here? P11 into P22 minus P12 into P21 is equals to 0, right? So P11, P22 minus P12, P21 is equals to 0. So option C is the correct option, right? Let me check any answers is there. Yeah, Saloni, right? Why what right? C is correct answer. Venkatesh, C is correct. Yes, right. Now let's move on to the next question. Yeah, see here, this is a little bit tricky question, and so much concept is also there in this one. Try to observe carefully, right? The maximum value of the determinant. So let me minimize this one. Yeah, let me compress. Yeah. Now I hope it is visible, I think, right? Yeah, the maximum value of the determinant among all 2 by 2 real symmetric matrices with trace 14. See here, all 2 by 2 real symmetric matrices given here. See here, all 2 by 2 real symmetric matrices given here. Okay, all means general case here given. So let me take one general matrix, one general 2 by 2 matrix. Let me take this one as some general 2 by 2 matrix, right? This is the 2 by 2 matrix, right? And what is the one more condition that is given already? This is the symmetric matrix. If I take this one as A, then what is the condition for symmetric matrix? A transpose is equals to A. A transpose is equals to A, right? In that case, A transpose is equals to A means here B should be equals to C. Here B should be equals to C, isn't it or not? If B equal to C, then this matrix will become symmetric matrix. Okay, fine. 2 by 2 real symmetric matrices we have taken, fine. And what we need to find? We need to find the maximum value of the determinant. First of all, try to find the value of determinant first. Okay, so let me write this matrix A as A, B. Okay, I am writing B only in place of C also. Okay, because B and C both are same. Okay, now this is the real symmetric matrix, and for that one we need to find determinant, not determinant, maximum value. Okay, first of all find determinant value here. First of all, that A is equals to AD minus B square. AD minus B square, right? This is the determinant value. First of all, we will see after that how to find maximum value for this determinant. Okay, first of all we are going to take determinant value as AD minus B square, right, as per the symmetric matrix concept. Right, now let us try to apply one more condition that is there in the question, which is nothing but trace is 14. Okay, what is the value of trace here? Here the value of trace given is 14. Trace is 14. Okay, what is meant by trace? What is meant by trace here? What is meant by trace? Yes, what is meant by trace here? Trace means sum of the diagonal elements. Okay, sum of the diagonal elements. A plus D is equals to 14. A plus D is equals to 14, right? That is also given in the question. With the trace 14. Right? So we have taken all the conditions. So if I try to find the maximum value, for this determinant, what I have to do? I have to apply the concept of maximum minima. Here for this one. But if you try to see here, total how many variables are there? A is there, D is there, B is there. So total 3 variables are there. So we need to find the maxima condition for a function which is having 3 variables. So by using this condition A plus D equal to 14, let me reduce this one to one more, reduce to 3 variables. Okay, D we can write as 14 minus A. 14 minus a we can write, right? So then get a will become equals to a into 14 minus a, right? A into 14 minus a minus b square, right? Now this is the actual determinant. This is the actual determinant. For this one we need to find again the maximum value for this determinant, right? Any answers? Yes. Yeah. So try to apply the concept of maxima here, maxima minima here. How to find the maxima or minima? We have to make the derivative is equals to 0. Derivative is equals to 0. But before going to equate derivative equals to 0, we should know. First of all, we should see how many variables are there in this one. How many variables are there in this one? If you try to see, a is one variable and b is one variable, and we have to apply. That means we have to apply the concept of maxima minima for two variables. Right? For two variables. See, what is the procedure for getting maxima or minima? The procedure is for getting function of two variable. Okay, for a function of two variable, what is the procedure? We are going to take this a function, okay, this mod a as a function, and for this function we are going to take the derivative with respect to a, partial derivative with respect to a and partial derivative with respect to b. That means we are going to calculate the values of PQRST, right? After that we should find RT minus S square also. We need to find RT minus S square value also. With this value, okay, if this value may be greater than 0 or less than 0 or maybe equals to 0, so based on this value, based on the value of RT minus S square, we are going to decide whether this function is having maxima or minima. If it is having maxima, then what is the maximum value and all. But if you try to see here, what is the determinant that is given here? That a is equals to AD minus B square. That a is equals to AD minus B square. That a is equals to AD minus B square, right? What is our target? We need to find the maximum value of determinant. See here, in place of minus, if we are having plus for suppose, then this AD term and this B square both are will become added and we are going to get maximum value. But because of this minus, some portion is going to get reduced from the product AD, So you may think if B is complex or purely imaginary, then I square is going to become minus 1 minus plus, so that you may feel, but there is no possibility because in the question itself it is given, yeah. Yeah, in the question itself it is given, it is a real symmetric matrix. That means all the entries should be real. That means this B also should be real. So somehow we are going to get somewhat little bit less value only because of that minus sign. So what I am going to take is, I would like to take this B value as 0. Because with that the maximum value will not get affected, right? Because no subtraction will be there if I take B is equals to 0, right? So this is what the thing. Even you follow this procedure, you are going to take this as function, and if you try to find PQRST values, then also you are going to get B value as 0 only. You can try, right? So if I try to take this B value as 0, then determinant value that A is equals to A into 14 minus A minus 0. That means this B term will not be there. Okay, so let me take this function as my required function, and we need to find maximum value for this one. How to find maximum value? We have to equate derivative should be equals to 0. The derivative value should be equals to 0. Okay, so try to find the derivative of this determinant with respect to A, because here A is the variable. Okay, so what we are going to get here? We are going to get 14 minus for A square, we are going to get derivative as 2A. Okay, so if I make it equals to 0, we are going to get 14 minus 2A is equals to 0. That means A is equals to 7. Okay, from that one we can calculate the value of D also, which is 14 minus 7. So D is also 7. Okay, so overall the product is going to be 7 into 7, 14. Okay, so this is the concept behind this question. Is it clear? For everyone? Yeah, Venkatesh, good evening. Is this question clear? Come on guys. Any doubts in this question? Any doubts? Is it clear, guys? Yes. Okay, let us move to the next question. Yeah. Try to solve this one here. Very beautiful question. Very beautiful question. We are going to solve this question in two different ways. Okay. So with the second way, we are going to get this question, this solution within 30 seconds. Within 30 seconds, we can able to answer this question easily. Okay. Try to solve this. Try to solve this, guys. Try to solve this. Try to solve this one. I am giving 30 seconds of time. Try to solve this. Otherwise, we are going to solve. Try to solve, guys. Yeah. Shaker. Okay. Try to solve this one here. Try to solve this one. Integral 0 to pi by 2. Integral 0 to pi by 2. Integral 0 to pi by 2. Sine of x plus y dx dy. Sine of x plus y dx dy. Okay. Any answers, guys? We are going to solve this problem in two different ways. With that, we can able to solve this question. We can able to answer this question in 30 seconds. Right? See here. So first of all, try to apply the integration with respect to x. Okay. So that what is the integration for sin x? It is going to become minus cos x, x plus y. Okay. And the limits are from 0 to pi by 2. Right? The second one is 0 to pi by 2 with respect to y. With respect to y. Right? So try to apply the limits here. Try to apply the limits. So minus of cos of pi by 2 plus y minus cos of 0 plus y. Okay. So this is the whole bracket. And outer side we are having still y terms. Y integration. Okay. So if you try to see what we are going to get here, we are going to get minus of minus cos y minus, sorry, this is sine, right? First one is going to be sine y. This is minus cos y. Again integral 0 to pi by 2 dy. So what we are going to get here, we are going to get integral 0 to pi by 2 sine y plus cos y dy. Sine y plus cos y dy. Right? Is it clear till here? Now next, integral 0 to pi by 2 sine y dy plus integral 0 to pi by 2 cos y dy. Now tell me, what is the answer for this one? What is the answer for this one? What is the answer for this one? Yeah, again we are going to get same, minus cos y, limits are from 0 to pi by 2, plus this one sin y 0 to pi by 2, and if you apply lower limit and higher limit, we are going to get 1 plus 1, which is 2. 1 plus 1, which is true. 2. Right? Is it clear, guys? Yes. Is it clear, guys? Yeah. This is the first way of solving, first method. Let us see the second method also. We can solve in a very easy way. But before solving in a second method, we should know few small topics, few small basics. What are those basics here? So let me write those basics here. See here, try to observe. If we are having any waveform, okay, which is of the form sinusoidal nature, that means 0 to pi, and if this value is found to be 1, right? Okay, then we can say directly the area under this curve is 2. Right? This is from 0 to pi, from 0 to pi, right? At the same time, if you try to find from 0 to pi by 2, if you try to find from 0 to pi by 2, its area is 1. Its area is 1. From pi by 2 to pi, its area is 1. Its area is 1. Okay? That means what is the meaning here? Integral 0 to pi sin y or sin x or sin theta, anything, will give you the value of 2. Will give the value of 2. Okay? At the same time, integral 0 to pi by 2, that means still here. Integral 0 to pi by 2, sin y value, sin y dy is equals to 1. Is equals to 1. Okay? Similarly, one more thing that we need to keep in mind, that is, this is cos. Okay? This is cos value. This is cos function from 0 to pi by 2. From 0 to pi by 2, the cos y value, integral 0 to pi by 2, cos theta or cos y, anything we can say, is equals to 1. Is equals to 1. Okay? If we know this one, then we can solve this question in 30 seconds. In less than 30 seconds, we can say. See here. Yeah. This is the actual problem, right? Yeah. This is the actual problem. Let me write one more method here. This is integral 0 to pi by 2, sin x plus y dx dy. Okay? Try to apply sin a plus b formula. Sin a cos b plus cos a sin b, right? This is from integral 0 to pi by 2. This is also from integral 0 to pi by 2, and this one is dx dy. Okay? First integrate only with respect to x. So what we are going to get here? We are going to get integral 0 to pi by 2 sin x dx. Integral 0 to pi by 2 sin x dx. What is the value here? 1. Okay? So cos y is going to be remained. At the same time, integral 0 to pi by 2. Integral 0 to pi by 2 cos x. How much? 1. So what is going to be remain here? Sin y. So the next is going to be the integration with respect to y. Integral 0 to pi by 2 cos y plus sin y dy. Okay? Again divide this one. So what we are going to get here? Again integral 0 to pi by 2 cos y. How much? 1. Integral 0 to pi by 2 sin y. How much? 1. So answer is 2. Is it simplified or not? Is it simplified or not? Is it clear now? Is it clear? Yes. I think the second method is more easier than first one, right? Yeah. So actually whatever we have seen here is, we have seen very small concepts we have seen. That means integral 0 to pi by 2, sin y dy is equals to 1, and integral 0 to pi sin y dy is equals to 2. Sin y dy equals to 2. Okay, what is the use of remembering these two? Okay, I will tell you. If I given with this waveform and asked you to find the average value. Okay, so this is 0, this is pi, this is 2 pi. This is the pi, 2 pi. Okay, this value is 1, let us suppose. Or let me take this value as Vm. Okay, so find average value. What is meant by average value here? The average value is equals to area by time period. Okay, just now we have seen from integral 0 to pi, if this magnitude is 1, integral 0 to pi, what is the area here? This area is 2, right? So it is having Vm, so 2 into Vm divided by time period is going to be pi here. So 2Vm by pi is the average. Okay, if I take one more waveform, which is like this. Yeah, this one is 1, integral 0 to pi, from pi to 2 pi its value is 0 for suppose. Okay, so then again find average value here. How to find average value? So here the area is going to be 2, as we know. If it is having Vm as a peak, then we are going to get 2 Vm. Okay, and what is the time period here? Here time period is 2 pi. Okay, time period is 2 pi. So that what we are going to get here? We are going to get Vm by pi, right? For half wave, this is half wave rectifier, this is full wave rectifier. The average value is Vm by pi and 2 Vm by pi, right? Simply we need not to take integrations and all the time. If we remember this area value as 2. If this area value as 2, then we can able to write the average value just like that, right? Is it clear, guys? I hope this one is clear and useful also. Yes. Shekhar, right? Prasad. Yeah. Is it clear? Can I move to the next one? Yeah. Let's move to the next question. See this one. Try to solve this one, guys. Try to solve this one. This is a very easy question. Very easy question. Just we need to know what is meant by, what is the concept behind this. What is the concept behind this? Let me minimize this. Yeah. Try to solve this one, guys. I need an answer. What is the answer for this one, guys? Yes, yes. Okay, Rajmohan. Yeah. Try to solve this one. Try to solve this question. A system of n homogeneous linear equations. A system of n homogeneous linear equations. Linear equations containing n unknowns. Okay, what is given here? N equations are there. Okay, n linear equations are there, and n unknowns also there. N unknowns also there. And one more thing, what is given? This is a homogeneous system. This is a homogeneous system, right? Homogeneous system will have non-trivial solution. Okay, this is the important thing that we should keep in mind as far as this question is concerned. Okay, non-trivial solution. Non-trivial solutions if and only if the determinant value of the coefficient matrix. Determinant value of the coefficient matrix. Okay, we need to say the value of that A provided if you are taking this n equations of n unknowns as system of linear equations is of the form Ax is equals to 0. As it is mentioned, it is a homogeneous system of equations. We are going to write this one as Ax is equals to 0. We are going to write Ax is equals to 0, right? So as it is homogeneous system, Ax is equals to 0, and we need to find the value of A, not A, value of determinant of A, provided this is having non-trivial solution. This is having non-trivial solution. What is the value of det A for having non-trivial solution? That is the question. Now tell me the answer. Now tell me the answer. Now tell me the answer. This is very easy here. Simple. Very simple concept. The homogeneous system is always consistent, and it is going to have either unique solution or infinite number of solutions. Okay, non-trivial means infinite number of solutions. Non-trivial means infinite number of solution, right? Non-trivial means infinite number of solutions. This determinant, if this determinant value is equals to 0, for suppose 0, then it is going to have non-trivial solution. If this determinant value is not is equals to 0, if this determinant value is not is equals to 0, then it is going to have unique solution. The system is having unique solution. Unique solution. As per the question, what is the solution it is having? Non-trivial solution. That means infinite number of solutions it is going to have. So that means the determinant value should be equals to 0. The determinant value is equals to 0. Yes, correct. Venkatesh, C is correct. Anik, C is correct. Prasad, D is wrong. Okay, try to see here. Very simple concept. We need to say the determinant of A. That's it. For having non-trivial solution. For having non-trivial solution. Right? Is it clear, guys? Can I move to the next question? Yes. Venkatesh, come on. Let's try to solve the next one. See this one. This is a very good conceptual question. This is a very good conceptual question. If we understand this one, then you will feel the beauty of differential equation. Try to solve this one, guys. Try to solve this one. Sai Teja, C is correct. Try to solve this question also. Try to solve this one. Try to solve, guys, this one. A curve passes through the point x equals to 1, y equals to 0, and also satisfying the given differential equation dy by dx is equals to x square plus y square by 2y plus y by x. Okay, then the equation describes. Here in this question, we are having two conditions. We are having two conditions. That is, the curve is passing through x is equals to 1 and y is equals to 0. This is the first condition, guys. This is the first condition. The curve is passing through x is equals to 1 and y is equals to 0. That means if a curve is passing through this point, this curve has to satisfy this point or not. Yes, right? So try to verify all the options by using x is equals to 1 and y is equals to 0. X is equals to 1 and y is equals to 0. Try to substitute in all options. Let me take option A here. What is the option here? Log of 1 plus y square by x square. Okay, where the value of y is 0. Okay, so if I try to place the value of y is 0, then it will become log 1 ln 1 is equals to 0. Okay, so left hand side it is 0. Okay, and what about right hand side? Right hand side 1 minus 1. This is 0. Okay, the first curve is satisfying the point x is equals to 1 and y is equals to 0. But what about option B? Option B. Option B is also having same term ln of 1 plus y square by x square. Right side also x minus 1 is there. So again, this is going to become 0, 0. Second curve also satisfying. Option B is also satisfying. Coming to C. Again, y square or y, there is no difference because y value is 0 here. Y value is 0. So let me write this one as ln 1 same 0. Again, right hand side no change, x minus 1. Similarly, last one also. If I keep y value as 0, ln 1 again 0, 0. So all A, B, C, D are satisfying the first condition, which is x is equals to 1 and y is equals to 0. Okay, so but one more condition is there. The curve is supposed to satisfy this differential equation also. That means we supposed to solve the differential equation and we need to find which curve is the satisfying. Which curve is satisfying? Is it correct, guys? Is it correct? Is it correct? Venkatesh, try to solve this one. Yes. Option A is correct, but yes, let me solve this one. Let us try to solve the differential equation here. Because this condition, the first condition is satisfying all the 4 options. So let us try to solve this differential equation now. dy by dx is equals to x square plus y square divided by 2y plus y by x right? We need to find the solution for this differential equation. As we know, the dy by dx related to first order, what method we have to apply? Tell me, guys. Variable separable or homogeneous, non-homogeneous or linear, exact, Bernoulli. Among these methods, which method we have to apply to find the solution? Tell me, guys. Yes. Try to solve this one, guys. Which method we have to apply? Which method we have to apply to find the solution for this equation? Which method we have to apply to find solution? Tell me, guys. Variable separable or homogeneous? Which one we have to apply? These methods are not going to be useful. We are going to find one new method, okay, to find this one. For this one, what we are going to do is we are going to take dy by dx as x square by 2y plus y square by 2y plus y by x, right? Next, dy by dx is equals to x square by 2y plus y by 2 plus y by x, okay? Now we are going to take y by x value as t. We are going to substitute the y by x value with t so that y is equals to x into t. Let me take the derivative with respect to x so that dy by dx is equals to x into dt by dx plus t. So now try to replace this substitution equation and dy by dx in this equation, so that this entire differential equation, which is in terms of x and y, will turns into x and t, right? What is the use? I will tell you. See this one. See here, what is the dy by dx value here? X into dt by dx plus t, okay, plus t is equals to x by y, okay? So we are going to write this one as x by 2 into 1 by t. 1 by t, because t value y by x. Here we are having x by y. So this is 1 by t plus y. What is the value of y here? Y is equals to xt, x into t, right? Divided by 2 plus y by x value as t. Y by x value as t. Is it clear, guys, till here? Is it clear? Is it clear, guys? Is it clear, guys? No, Raj Mohan. With homogeneous, we cannot solve this. That's why we are trying to apply this method. We are going to take y by x as t. We are going to take y by x value as t. No, linear also we cannot apply. It seems like we can apply linear, but we cannot able to separate the y value here. Okay. So because y is having y square. Of course, y square can be eliminated, but we cannot separate with y. Okay. Okay. Is question not clear? See, guys, is it visible clearly? Is it clear, guys? Yeah. Try to solve from here and tell me the answer. Try to solve from here and tell me the answer. Yeah, let me continue. So we are going to have this t and this t both will get cancelled. T both will get cancelled. So that what we are going to get here, we are going to get x into dt by dx is equals to x by 2t plus xt by 2, right? So if you try to see x, okay, 3 will get cancelled. So that what we are going to get here, dt by dx is equals to 1 by 2t plus t by 2. 1 by 2t plus t by 2. Now tell me which method we have to apply. Now it is simplified. Now tell me which method we have to apply now. Variable separable or linear? Tell me again. Now which one we have to apply? In order to solve this equation, which method we have to apply? Variable separable or linear? Yeah, tell me the answer here. Which method we have to apply here? Which method we have to apply? We can apply variable separable here. We can apply variable separable so that we can get the answer very easily. Let me apply variable separable here. dt by dx is equals to, so if I multiply with t, we are going to get t square plus 1 by 2t as denominator, right? So all t variables are there and dt is there, dx is there. So let me separate the variables with respect to their respective derivatives, so that we are going to get 2t by t square plus 1 into dt is equals to dx. Right? Now variables are separated with their respective derivatives. Then what we need to do? Simply take the integration. And tell me the answer, guys. Take the integration and tell me the answer. Yes, Soloni, variable separable is enough here. Variable separable is enough. No need to apply linear and all. Try to take the integration and let me know the answer. What is the answer here? Here we are going to get log of t square plus 1 is equals to x plus c. Log of t square plus 1 is equals to x plus c, where we have taken y by x value as t. So let me replace the t value here, so that what we are going to get, log of 1 plus y square by x square is equals to x plus c. This is what the solution for the given differential equation, right? So by using the first condition, whatever we have taken, x is equals to 1 and y is equals to 0. Whatever the condition given that this curve is passing through x is equals to 1, y is equals to 0. So we have to substitute this x equal to 1 and y equal to 0 in this equation, and we need to find the value of c here. We need to find the value of c. Okay, so we need to replace the c value here in this equation. We need to replace in c. So try to see the options. Try to see the options here. Yeah. Try to see the options. Right side, all the options are having x minus 1 as a common term. X minus 1 as a common term. Coming to left hand side, if we see what we got here, ln of 1 plus t square we got. That means ln of 1 plus y square by x square. Y square by x square on the left hand side, and right hand side x minus 1. Tell me the answer now. Tell me the answer. Tell me the answer. No, Ankit, Gautam, why it is known as linear? No. Actually, I am not saying linear and all. Which method we have to apply to solve the differential equation? I am saying. Which method we have to apply? Okay, that is what I am asking. Right? Yeah. Is it clear, guys? Is it clear? Is it clear, guys? Come on, guys. Next question. See here. This is a very easy question. We can solve this question just like that. But we need to know the simple properties of expectation. The simple properties of expectation. Try to solve this one. 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 I hope the question is clearly visible, I think. Right? Yeah, try to solve this one here. What is given in this question? Expectation of 2x plus y is equals to 0, and expectation of x plus 2y is equals to 0. X plus 2y is equals to 0, and from these conditions we need to find what is the value of expectation of x plus expectation of y. This is what we need to find. I am expecting answer, guys. Very easy question, this one. Tell me the answer, guys. Rajmohan, Ankit, what is the answer? What is the answer, guys? We are given with two conditions here. Expectation of 2x plus y is equals to 0, and expectation of x plus 2y is equals to, sorry, here this is not 0, this is 33. This is 33. Okay, by using those two conditions we need to find the value of expectation of x plus expectation of y. What is the answer, guys? Come on, guys, come on. Very easy question. Very easy question. Not even 30 seconds are required. Yes, Ankit, Anik, correct. 11 is correct answer. So in order to solve this question we should know only two basic properties, that is expectation of x plus y is equals to expectation of x plus expectation of y. Okay, and at the same time expectation of cx is equals to c into expectation of x. C into expectation of x, right? So if we know these two formulas and we try to apply these formulas for these two given conditions, then we can say this answer just like that. Okay, let me take the first condition, which is expectation of 2x plus y. Expectation of 2x plus y, which we can write as expectation of 2x plus expectation of y, right? By using this property, right? So again, expectation of 2x, by using this property we can write this one as 2 times of expectation of x plus expectation of y, right? So how much this value? This value should be equals to 0. This is the first condition that is given in the question. So let me apply these properties for the second condition. So what we are going to get here, we are going to get expectation of x plus 2 times of expectation of y is equals to 33, is equals to 33. So this is the second condition. This is the second condition. So what we need here, we need a value of expectation of y and expectation of y, and we need sum of these two values. Sum of these two values. We are having two equations with two variables, with two unknowns, e of x and e of y. We can solve this one. We can solve this one, but we need not to solve. We need not to solve directly. We can say the answer. Come on, guys. Now tell me the answer. Yes, Rajmohan, 11 is correct. Right. How to get the answer here from these two equations? Simply try to add these two portions, so that what we are going to get here, 3 times of expectation of x plus 3 times of expectation of y is equals to 33 plus 0, which is 33. So 3, 3, 11. So expectation of x plus expectation of y is equals to 11. Is equals to 11. Right? Is it clear, guys? Yes, 11. Is it clear, guys? Remaining guys, is it clear? Very simple question. Yeah. Let's move to the next question. See this one. This one is also very beautiful question, we can say, in differential equations. Try to solve, guys, this one. Try to solve this one. Let me write the differential equation here, which is k square into d square y by dx square is equals to y minus y2. Y minus y2, and two boundary conditions were given. Two boundary conditions were given, and here k value and y2. K value and y2, those two are constants. Those two are constants, right? So try to solve this one, guys. Try to solve this one. Anik, try to solve this one. Very beautiful question. Try to solve this one here. K square into d square y by dx square is equals to y minus y2. Y minus y2. We need to find the solution for this one along with the initial conditions. Along with the initial conditions. Come on, guys. What is the answer? What is the answer for this one? What is the answer for this one? As this term, this differential equation is having d square y by dx square. Okay, so we have to apply. Yeah, good evening, Vikas. Try to solve this question. Anik, sine hyperbola. No, try to solve this one. Try to solve, and after that try to tell the answer. Try to solve the question, and after that give me the answer. Okay. Let me solve this question. Let me solve this question. So here this is d square y by dx square term is involved. So it will come as k square into d square y by dx square minus y is equals to minus y2. Minus y2, because here y2 is a constant. Y2 is a constant, right? So as per higher differential equation, we need to find the complementary function and particular integral also. We need to find complementary function and particular integral also. For that one, let me write this one as k square into d square y minus y is equals to minus y2. Okay, so let me separate y here, so that what we are going to get, k square d square minus 1 into y is equals to minus y2. Is equals to minus y2, right? So for this one, we need to find complementary function and particular integral also. Particular integral also. Now try to solve this one, guys. Now try to solve this one. Rajmohan, try to solve this one. C is not the correct answer. Try to solve this one. Beautiful question. Because, come on. Yeah, first of all, let me find particular integral. Let me find particular integral, which is very easy to find. Which is 1 by k square d square minus 1 of minus y2. Here y2 is constant, that is mentioned in the question. Y2 is constant. Okay, so I am adding e power 0x here. E power 0x. Okay, so we can write minus y2, and in place of d we supposed to keep this 0. Okay, we need to place 0, so that what we are going to get, k square into 0 square minus 1. So minus y2 by minus 1, which is nothing but y2. Okay, this is the particular integral. This is the particular integral. Now we need to find complementary function. We need to find complementary function. For that one, what we need to take? We need to take auxiliary equation. Auxiliary equation, which is k square into d square minus 1 is equals to 0. Okay. So if I try to find the value of d here, d is equals to plus or minus 1 by k. Plus or minus 1 by k. Now y complementary function is equals to c1 into e power 1 by k into x plus c2 into e power minus 1 by k into x. Right? Now ultimately we got the complete y, which is y is equals to c1 e power 1 by kx plus c2 into e power minus 1 by k into x plus y2 plus y2. This is the complete solution. This is the complete solution. Right? Now tell me with which option it is matching. Bharat, these marathon sessions are common for electrical and EC also. Every day morning at 10 a.m. for especially for EC guys, one marathon session is starting. Okay, by Chaitanya sir. You can join the session for ECE. The remaining session is common for both EC and electrical. Right? Try to solve this one, guys. Try to solve this one. Now, it is matching with which one? It is having exponential terms, but we need to find the value of C1, C2 also by using the initial conditions. What are the initial conditions? At x is equals to 0, y value is y1. At x equals to infinity, y value is y2. Okay? Try to apply these two initial conditions so that we are going to get the answer here. Okay? We are going to get the answer. See here, let me apply first initial condition. So, which is equals to y1 is equals to, okay, c1 into e power, what is the value of x here? 1 by k into 0 plus c2 into minus 1 by k into 0 plus y2. Okay, what about the second one? At x equals to infinity, y value is y2. Okay, y value is y2 at x is equals to infinity. So let me try to apply here c1 into e power infinity. Okay, because infinity into 1 by k, infinity only, plus c2 into e power minus infinity plus y2, right? So if you try to see here, what we are going to get from first equation, we are going to get y is equals to c1 plus c2 plus y2. Okay, so from second equation, what we are going to get from second equation, this e power minus infinity is going to be 0. See here, if you try to see here, this is c1 into e power infinity. C1 into e power infinity. E power infinity is supposed to become infinity. If it is infinity, how to find c1, c2? Because c1, c2 already gone. C2 term already vanished. So in order to get c1, in order to make this value finite, we supposed to take c1 as 0. Okay, if we take c1 value as 0, then what we are going to get here, we are going to get y is equals to, or this one is y2. Okay, this one is y1, right? This one is y1. So if c1 value is 0, then y1 is equals to c1, which is 0 plus c2 plus y2. Okay, so c2 is equals to y1 minus y2. C2 is equals to y1 minus y2, and c1 value as 0. Right? C1 value as 0. Now try to write here in this one so that we are going to get complete answer. Y is equals to c1 0, c2 value y1 minus y2 into e power minus 1 by k into x plus y2. Okay, this is the final answer. Is it clear, guys? Is it clear? Whenever we are having such kind of conditions like this, we have to make c1 0 in order to make this term finite. Right? Yes. Let me move on to the next question. Is it clear, guys? Is it clear? I hope this is clear. I hope this is clear. Yeah. Let us move on to the next question. See this one. This is very beautiful and small question. We can solve this one just like that. Tell me the answer, guys. Tell me the answer. What is the answer for this one? Yeah, Anik. Right. Shekhar, try to solve this one. The probability density function P of x of a random variable x is shown in the figure. What is the value of alpha? We need to find the value of alpha here. Come on guys, try to solve this one. Very easy question. Very easy question. Try to solve this one. Here the probability density function is given. Okay, it is having its shape like a triangle from A to A plus C, A plus B. Okay, its magnitude is alpha. Yes guys, tell me the answer. Very easy question. Very easy question. Yes, Saloni, try to say the answer. What is the answer here? First of all, what is the concept behind this question? The concept behind this question is sum of the probabilities equals to 1. Sum of the probabilities equals to 1. Sum of the probabilities equals to 1. Based on that, we can say the sum of the probabilities is equals to 1. We can say for probability mass function, probability density function, we can write the complete area under probability density function is going to be 1. That means from minus infinity to infinity, P of x dx is equals to 1. The area under probability density function is equals to 1. Okay, that is coming from the sum of the probabilities is equals to 1. Right? So now try to apply this condition for this function and try to tell the answer. What is the answer, guys? Yes, Anik, triangle area should be equals to 1 because it's a probability density function, right? So try to find the area here. How much the area will become? This is half, right? The base is C and the height is alpha is equals to 1. So alpha equals to 2 by C. 2 by C, right? Is it clear, guys? Is it clear? Yes, 2 by C is correct. So let's move on to the next question. See here this one. This is also very basic question only, in fact. Is this question visible, guys? Try to solve this one. Yes, A. Arpit Singh, A is correct. Lasya, A is correct. Vikas, A is correct. Shekhar, A is correct. Good, good, good. Try to solve this one also. A box contains 5 black balls and 5 red balls. A box is having, let me take this one as a box, and it is having 5 black balls and 5 red balls. It is having 5 black balls and 5 red balls. What is the experiment here? What is the experiment here? The experiment is we need to pick 2 balls. 2 balls are randomly picked from one after another from the box without replacement. That means we need to pick 1 ball and we need to pick 1 more ball without replacement. Without replacement, right? That is what the experiment, picking the 2 balls from box. Okay, this is the experiment. And what is the favorable event? Favorable event is the probability of both the balls being favorable event here. Favorable event is both the balls being red. Both are red. Both are red. Okay. Try to tell me the answer here. What is the answer? Yes. Anik. Correct. So here, first of all, we should try to write what is the total number of possibilities are there to pick 2 balls out of 10 without replacement. So total in the box 10 balls are there. Okay. So to pick the first ball, I am having 10 chances. Any ball can come from out of these 10 balls. Okay, there is no replacement. That means we should not keep again in the box, and we have to pick 1 more ball. So to pick that 1 more ball, we are having 9 options here. Okay, so in the same case, now for the favorable cases, we should see only red balls because our probability we are finding for both the balls red. Okay, so in the first case, in the first trial, we are going to have 5 balls, 5 red balls. After that, we are going to not replace, so we are going to have 4 red balls. 4 red balls, right? So this is 2 by 9. This is 2 by 9. Of course, very simple question. So answer D is correct. Yes. Is this clear, guys? Is this clear? Yes. Arpit, D is correct. How? D is correct. Yes. Let me solve one more question. See here. This is also a beautiful question, we can say. A small concept is there. We have to understand it properly. Try to see this one. it is estimated that the average number of events during a year is 3. What is the probability of occurrence of not more than 2? Not more than 2, important here. Not more than 2. Not more than 2. Not more than 2 events. For a 2-year duration. Assume that the number of events follows Poisson distribution. Okay, whatever the question that will come from random variables and distributions and all, we should try to read 2 times. At least we should try to read 2 times, right? So here in this question, the random variable is following Poisson distribution. The random variable is following Poisson distribution. First one, we should be clear with this distribution, right? And we should try to find what value, that means what is the random variable, which one we have to assign for random variable. Okay, here what it is saying, the number of events we are going to take as random variable. The number of events we are going to take random variable. And one more thing, not more than 2. Not more than 2, that means probability of x less than or is equals to 2. Not more than 2, that means it can be 2, but it should not be beyond 2. Not more than 2. Okay, 2 is okay, but not more than 2, right? That is the condition. Okay, so this is the Poisson distribution, and random variable is number of events, and we need to find probability of getting number of events less than 2, right? Less than 2 for a 2 years. This one is also important. Try to say the answer, guys. Try to say the answer. Yes, Sujini, B is correct. Yes, 0.062 is correct. So let me try to explain here. Here the average number of events are given. Okay, so average number of events for 1 year is 3. For 1 year is 3, right? But here what is asking here, what is the probability of occurrence of not more than 2 events over 2 years? Over 2 years here. Okay, so over 2 years. For 1 year 3. For 2 years, this is going to be 6. This is going to be 6. What is this 6 here? This 6 is the average number of events. Average number of events for 2 years. Average number of 2 years. So in Poisson distribution, mean value is equals to lambda. This is what important. This lambda value is important. In this question, lambda is equals to 6. Right? So we are having lambda value, and we should find P of x less than or equals to 2. Then we can solve this answer just like that. P of x less than or equals to 2 is equals to P of x is equals to 0 plus P of x is equals to 1 plus P of x is equals to 2. Okay. What is the Poisson distribution formula? P of x is equals to R. P of x is equals to R, we can write e power minus lambda into lambda power r by r factorial. Okay. Try to apply this formula for this one and try to substitute lambda as 6 and tell me the answer, guys. Tell me the answer. Tell me the answer here. So here we are going to get e power minus lambda into lambda power 0 by 0 factorial plus e power minus lambda into lambda power 1 by 1 factorial plus e power minus lambda into lambda square by 2 factorial. Okay. If we keep the lambda value as 6, we are going to get the answer as 0.062. 0.062. Is it clear, guys? Is it clear? Is it clear? Yeah, let's move on to the next question. See this one. This is also very basic question only. If we know the properties of Laplace transform, we can solve this question easily. Right? So the Laplace transform of e power omega t is 1 by s minus omega, that is given in the question. Now we need to find the Laplace transform for t into cos ht. Yes. Arpit, try to solve the next question. Easy question. Very easy question. If the Laplace transform of e power omega t 1 by s minus omega and Laplace transform of t into cos ht. First of all, let me write cos ht as cos ht as e power t plus e power minus t by 2. Okay, right? So what is the Laplace transform for e power t? E power t is 1 by s minus 1. Okay, so for e power minus t, it is going to become 1 by s plus 1, 1 by s plus 1. So combinedly for e power t plus e power minus t by 2, it is going to become 1 by s plus 1, 1 by s minus 1 plus 1 by s plus 1 whole 1 by 2, 1 by 2, right? Yes. Now we need to apply this property. We need to apply into t property. Okay, for a function f of t, if the Laplace transform is f of s, then for t into f of t, it is minus d by ds of f of s, d by ds of f of s. Now try to apply this property and let me know the answer. What is the answer here? What is the answer? Yes, Anik, option A is correct. Option A is correct. Option A is correct. Come on guys, remaining guys, try to say the answer. Here minus d by ds of whatever we got here, 1 by 2 into 1 by s minus 1 plus 1 by s minus 1, sorry, s plus 1. Okay, so 1 by 2 into minus of 1 by 2 into this one, we are going to get 1 by s minus 1 by s minus 1 whole square plus this one also minus 1 by s plus 1 whole square. Okay, so that we are going to get the final answer as 1 plus s square by s square minus 1 whole square. This is the answer. We can simplify this one easily. Okay, is it clear guys? Yes, because A is correct. Is it clear guys? Remaining guys, let us move on to the next question. See here, this is very beautiful concept, very beautiful concept. Actually this question is from limits. Try to solve this one guys. Take this one as challenging question, because try to answer this question. Arpit, Anik, come on guys, answer this question. Y is equals to e power x. Here we are having y is equals to e power x, e power ax. Then we need sum of the series, that means some value dy by dx plus d square y by dx square plus and so on, plus d power n by d nth derivative as approach 2y as n tends to infinity. Then the value of a is, here one condition is here. Here one condition is given. If n is tending to infinity, we should take s value as 2y. We take s value as 2y. Very beautiful concept this one. Try to solve this one guys. Rajmohan, try to solve this one. If n is equals to 1, for suppose, if n is equals to 1, then s is equals to dy by dx. Okay, if n is equals to 2, if n is equals to 2, then s is equals to dy by dx plus d square y by dx square, d square y by dx square. Okay, so based on the value of n, this summation will change, this summation will change. Okay, so at the same time, if n approaches infinity, then we should take the value of s as 2y. We should take the value of s as 2y. So this is the condition, this is the condition. Okay, for all the case, if n is 1 or 2 or 3 or 4 or 5, at least let us try to find what is dy by dx and d square y by dx and all. Okay, so erase this one. So let me find dy by dx here. What is the value of dy by dx? A into e power ax, right? What is the d square y by dx square? Which is a square into e power ax. Okay, and so on. If I take nth derivative, it will become a power n into e power ax, right? A power n into e power ax. Now try to find if n value is infinity. N value is infinity. what we are going to get here? We are going to get this one as a power infinity into, a power infinity into e power ax. These are the values, right? These are the values. These are the values. Now let me write what is the s value here. What is the s value if n is tending to infinity? That is the condition that is given, right? So if n is tending to infinity, we should write s value as dy by dx plus d square y by dx square plus and so on, plus until infinity we should write d infinity y by dx infinity, right? This is what we should write. This is what we should write. So we have derived already what is meant by dy by dx and d square y by dx square and all. So let us try to replace here. So we are going to get a into e power ax plus a square into e power ax plus a cube, almost it will come, right? And so on, a power infinity into e power ax, right? See here, we are taking the condition for n tends to infinity. N tends to infinity. What is given in the question? As n tends to infinity, s should approach 2y. S should approach 2y. Okay? As we are taking this condition for n tends to infinity, what is the value of s here? What is the value of s? 2y. That is given in the question. That is given in the question. Try to see this one. That is given in the question. Approach 2y as n tends to infinity. As n tends to infinity. Here we are writing the s for n tends to infinity. For n tends to infinity, s will become 2y, right? So here, let me try to take e power ax as common. E power ax as common. So that what we are going to get here, a plus a square plus a cube plus and so on plus a power infinity. Now can anyone tell me what is the answer? Now anyone can tell me what is the answer? Yeah, Arpit, Rajmohan. Yeah, Anik. Tree, see here. See this one. See this one. Here we are going to write 2y is equals to e power ax into, try to see this one. Can you able to identify any form? A plus a square, a cube plus and so on till infinite number of terms. Sum of infinite terms in GP, a by 1 minus r. Here the first term a is going to be a only. 1 minus a, right? Is it clear, guys? Yes. Now we are going to get 2y is equals to e power ax. Okay, so what is the y here? What is the y here? Or we can write 2y is equals to this a power ax we can write as y, okay, and this is a by 1 minus a. A by 1 minus a, this one will get cancelled. This one will get cancelled. So we are going to get a by 1 minus a is equals to 2. A by 1 minus a is equals to 2, right? So with that, what we are going to get here, we are going to get a is equals to 2 minus 2a. A is equals to 2 minus 2a. So that 3a is equals to 2 and a is equals to 2 by 3. A is equals to 2 by 3. Is it clear, guys? Is it clear? Is it clear? Yes, Anik, 2 by 3 is correct. Arpit, 2 by 3 is correct. How is this question? Yeah. Remaining, guys, is it clear? Is it clear, guys? Is it clear? Answer is 2 by 3. Yeah. Option C is correct. 2 by 3 is correct answer. C is correct. Right? That's it, guys. That's it for today. I hope you guys enjoyed this session. Yeah, Saloni, 2 by 3 is correct. Yeah. Yes. Thank you. Thank you so much, guys. Thank you so much for watching the session. Tomorrow at 10 p.m. again, Chaitu sir is going to start marathon at 10 a.m. Okay? Thank you, guys. Thank you so much. Thank you. Thank you, Vikas. Thank you.